At first light, the summit appears through the mist as a dark staircase rising above the green folds of West Java. Stone terraces climb the crown of the hill. Long volcanic columns lie stacked, tilted and fitted into walls, pathways, platforms, and narrow enclosures. From a distance, the shape invites an immediate comparison. It looks geometric, it looks deliberate, it looks like the upper surface of something larger waiting below. That impression has carried Gunung Padang far beyond the forests and villages that surround it. In headlines, documentaries, and online discussions, the site has become a buried pyramid, an Ice Age monument, perhaps even the work of a civilization older than Egypt by tens of thousands of years. Yet the real landscape is quieter and more complicated. There is no desert here, no sand sea swallowing a forgotten monument, no exposed triangular facade emerging from dunes. Gunung Padang is a wooded volcanic hill, wet with tropical rain, and crowned by a genuine megalithic complex whose visible stones are remarkable enough without turning the entire mountain into a lost monument of prehistory. The mystery begins because two truths sit so close together that they are easily confused. The first is secure people in the past shaped the summit. They moved large pieces of volcanic rock, arranged them into terraces, marked routes across the hilltop, and created meaningful spaces. The second claim is far more dramatic, that the visible terraces are merely the latest skin of a vast man-made pyramid, extending deep into the hill, with its earliest construction beginning during the last ice age. That idea is not established archaeological fact. It is disputed interpretation built from geophysical surveys, drill cores, trenches, and radiocarbon dates whose connection to human construction remains uncertain. Before we go deeper, take a moment to like the video and subscribe, if this is the kind of history and mystery you enjoy, because the question at Gunung Padang is not whether ancient people could build impressive monuments. They could. The real question is whether the buried layers beneath this summit are architecture at all. Standing on the terraces, that distinction can feel almost artificial. The stones underfoot are not shapeless rubble. Many are long, narrow columns formed naturally when volcanic rock cooled and fractured. Their regular sides make them convenient building material. When placed side by side, they can resemble beams, posts, lintels, or paving blocks. Some point in orderly directions. Others form retaining walls along the stepped platforms. The result is a place where geology and human design overlap so closely that each can be mistaken for the other. Nature produced the stone. People selected, transported, and rearranged at least part of it. But how far downward does that human activity continue? Does it stop near the terraces, include earlier buried surfaces, or extend through a sequence of constructed layers? Those questions gained extraordinary force when researchers proposed that the hill contained several construction phases separated by immense spans of time. In the most sensational version, the deepest layer dated back roughly 20,000 years or more, making the site older not only than the pyramids of Egypt, but also than agriculture, pottery, cities, and nearly every accepted milestone of monumental architecture. If true, the consequences would be enormous. Archaeologists would have to explain how communities in Ice Age Southeast Asia organized labor, designed massive structures, shaped stone on a grand scale, and left almost none of the ordinary debris expected from such a project. Tools, living surfaces, hearths, manufacturing waste, burials, and secure architectural joints would become urgently important. A date alone would not be enough. An extraordinary monument requires an archaeological world around it. This is where the story becomes less like the discovery of a hidden pyramid and more like a test of how evidence works. Beneath any ancient site, old carbon can survive in soil. Roots die, forests burn, organic matter moves through cracks, sediment is buried, disturbed, and redeposited. A radiocarbon measurement can tell researchers when a particular piece of organic material stopped exchanging carbon with the atmosphere. It cannot, by itself, reveal why that material is where it is. Charcoal sealed inside a constructed floor may date human activity. A root remnant in natural soil may date vegetation. Organic material washed into a fissure may be older or younger than the surrounding deposit. The laboratory number can be precise while its historical meaning remains uncertain. At Gunung Padang, the oldest dates became famous because they were treated as ages for buried construction. Critics argued that the samples came from soil without a secure connection to artifacts. Mortar, prepared floors, post holes, occupation debris, or structures proven artificial. The dates could establish the age of organic material in the hill, but not the age of a pyramid. This was not a minor objection. It struck at the bridge between geology and archaeology. If the buried formations were natural volcanic deposits, ancient soil within them would not be surprising. If they were built walls or chambers, the evidence demonstrating construction had to exist independently of the dates used to assign it an age. The controversy eventually reached a point that few dramatic archaeological stories ever do. The scientific paper that gave the Ice Age pyramid claim its most formal presentation was withdrawn by the journal that published it. The retraction did not prove that every buried feature at Gunung Padang was natural, nor did it erase the visible megalithic site. It meant that the evidence presented was not sufficient to support the extraordinary construction chronology. The authors disagreed, and debate continued in public, but the status of the claim changed. A withdrawn paper cannot be treated as secure confirmation simply because its most striking numbers remain easy to repeat. That change did little to slow the legend. The idea of a 25,000-year-old pyramid had already escaped into wider culture. It appeared in articles as videos and social media posts long after the study had been challenged and removed. The phrase "oldest pyramid in the world" proved more durable than the explanation of why the dating was disputed. This is a familiar pattern in archaeology. A spectacular claim can travel across the world in hours. Its correction moves slowly, carrying caveats and the less satisfying message that the evidence remains incomplete. Gunung Padang became a monument not only in stone, but in the modern imagination, a place where the desire for a lost civilization met the difficulty of reading a volcanic hill. Yet dismissing the entire site would be as careless as accepting every grand claim. Something important happened on this summit. Human hands organized the stone terraces. Communities climbed the hill, crossed its platforms, and returned often enough for the place to enter local memory and national debate. The surviving arrangement suggests ritual, gathering, authority, or all three. Though scholars still debate the precise functions of its spaces, the upper monument deserves study on its own terms, not merely as the exposed tip of a hypothetical pyramid. Its real history may be younger and more regional than the legend suggests, but that does not make it small. Ancient people did not need to build an Ice Age superstructure for the hill to matter, so the investigation begins not with a pyramid beneath the sand, but with a more demanding image of forested volcanic summit where natural stone and human intention have become entangled. The terraces are real. The deeper architecture is unproven. The old carbon is real. Its meaning is disputed. Between those facts lies the entire problem. To understand what Gunung Padang may be, it is first necessary to understand the world before Egypt's pyramids, when people in many regions were already gathering, building, remembering, and turning landscapes into places that outlived them. Long before the first Egyptian pyramid rose above the floodplain, people were already changing the shape of the world around them. They raised stones, cut ditches, arranged posts, buried their dead beneath mounds, returned to the same ceremonial places across generations, and transformed hills, springs, caves, and open plains into landscapes filled with memory. Monumental building did not begin with pharaohs, and it did not require a kingdom in every case. That fact matters at Gunung Padang, because the question is not whether humans before dynastic Egypt were capable of coordinated construction. Archaeology has already answered that. The harder task is identifying what kind of construction occurred, when it happened, and whether the evidence belongs to the monument being claimed. Egypt's pyramid tradition began in the 3rd millennium BCE, after centuries of political consolidation, agricultural expansion, administrative growth, and experimentation with elite tombs. The step pyramid of Djosret Saqqara, built around the 27th century BCE, represents a decisive transformation. Earlier Egyptian rulers had been buried beneath rectangular mud brick structures commonly called mastabas. Djoser's builders stacked and enlarged stone forms until the tomb complex became a rising staircase of limestone. Later engineers under rulers such as Sneferu experimented with angles, foundations, chambers, and methods of moving immense quantities of material. By the time the Great Pyramid of Khufu was constructed at Giza, pyramid building had become part of a highly organized state system, supported by taxation, labor administration, quarrying, transport, surveying, food production, and written records. That sequence leaves little room for the idea that Egypt's pyramids suddenly appeared without precedent. Yet it also shows why calling any ancient stepped hill a pyramid can be misleading. In Egypt, a pyramid belongs to a recognizable architectural tradition. Its builders prepared foundations, laid courses of stone, created internal passages, constructed chambers, established temples and causeways, and integrated the monument into a broader funerary complex. Archaeologists can examine quarry marks, tool traces, worker settlements, food remains, administrative seals, transport routes, and changing construction techniques. The pyramid is not identified by shape alone. It is identified by an entire network of physical and cultural evidence. Thousands of years before Djoser, however, communities elsewhere were already creating large ceremonial spaces. At Göbekli Tepe in southeastern Anatolia, people erected monumental stone enclosures beginning around the 10th millennium BCE. Massive T-shaped pillars were carved with animals, human features, abstract signs, and elaborate reliefs. The builders lived before the full development of settled farming in the region, yet they gathered labour, selected stone, planned circular structures, and repeatedly rebuilt the site. Göbekli Tepe overturned a simple older assumption that monuments could only emerge after agriculture produced permanent villages and powerful rulers. It demonstrated that ritual gathering itself may have helped communities cooperate at a scale once thought impossible for mobile or partly settled groups. Even there, uncertainty remains. Scholars still debate how many people lived permanently near the site, how the enclosures were used, and whether feasting, ancestor rituals, seasonal aggregation, or social competition drove the construction. But the human origin of the structures is not in serious doubt. Pillars were quarried, carved, transported, set into prepared sockets, and arranged in clear architectural plans. Stoneworking debris survives. Floors were prepared. Later structures cut into earlier ones. The monument's great age is supported not by isolated ancient soil alone, but by radiocarbon samples connected to archaeological deposits, construction phases, and occupation contexts. Other early sites tell different stories. At Jericho, communities built a massive stone tower and wall during the early Neolithic, long before Egyptian pyramids. The tower's exact purpose remains debated. It may have had defensive, symbolic, communal, or environmental functions. Whatever its meaning, the structure shows deliberate planning and sustained labor. At sites across the Levant and Anatolia, people constructed communal buildings, plastered floors, stone benches, shrines, and carefully organized settlements. In Europe, later Neolithic communities raised long barrows, passage tombs, stone circles, and alignments. Across the Sahara and Nile Valley, pastoral groups marked landscapes with burials, standing stones, hearths, and ceremonial arrangements that reflected seasonal movement through environments far greener than the desert known today. Nabta Playa, west of the Nile in southern Egypt, is especially important because it reveals a deep ceremonial history in northeastern Africa before the pharaohs. During wetter phases of the Holocene, pastoral communities gathered around seasonal lakes. They left behind hearths, cattle burials, stone features, and alignments that may have carried social or astronomical meaning. These were not pyramids, and they were not products of a centralized Egyptian kingdom. They were expressions of communities adapting to changing water, animals, movement, and ritual obligations. As the Sahara became increasingly dry, populations shifted toward more reliable water sources, including the Nile Valley, where village life and regional cultures gradually developed. The people who eventually formed dynastic Egypt inherited a landscape already rich in tradition. Before kings ruled a unified state, communities along the Nile cultivated crops, kept animals, traded materials across long distances, produced distinctive pottery, and created cemeteries that reveal growing social differences. Badarian, Mahdi, and Naqada traditions were not simply primitive rehearsals for pyramid building. They were complex regional worlds with their own customs, technologies, exchange networks, and beliefs. Over centuries, some settlements expanded, elites gained influence, symbols of authority spread, and political centers competed. Around 3100 BCE, Egypt became increasingly unified under rulers whose power was expressed through writing, administration, warfare, ritual, and monumental burial. This longer record reveals two dangers in comparing Gunung Padang with Egypt. The first is underestimating prehistoric people. Communities without metal tools, writing, or kings could still organize impressive construction. They could move heavy stone, coordinate labor, maintain sacred places, and preserve knowledge across generations. No responsible assessment of Gunung Padang should begin with the claim that Ice Age or early Holocene people were incapable of building monuments. Human ingenuity is much older than the Pyramid Age. The second danger is assuming that because early monument building was possible somewhere, every ancient-looking formation must be a monument. Göbekli Tepe does not prove Gunung Padang's deepest layers were constructed. Jericho's tower does not validate every buried geometric anomaly. Nabta Playa does not transform natural volcanic terraces into architecture. Archaeology works through context, not possibility alone. A demonstrated early monument provides a comparison, not a certificate of authenticity for another site. This distinction is often lost because the phrase older than Egypt carries enormous emotional power. Egypt's pyramids has become a popular boundary marker between ordinary prehistory and civilization. Anything older seems to promise a forgotten world that should not exist. But the archaeological record no longer supports such a simple boundary. Monumental behavior emerged in different places, at different times, and for different reasons. Some structures were tombs, others were gathering places, ritual enclosures, territorial markers, platforms, towers, or forms whose purposes remain uncertain. There was no single invention of monumentality spreading outward from one source. What survives in the record suggests that people began shaping meaningful landscapes long before they built cities. They returned to prominent hills, springs, caves, and plains because such places connected communities to ancestors, seasons, animals, water, and the sky. A natural feature could become sacred without being entirely artificial. A hill could be modified, terraced, crowned with stones, and used for ceremonies while remaining geologically a hill. That possibility is especially relevant at Gunung Padang. This site need not be either a wholly natural formation or a completely constructed pyramid. Human beings often work with landscapes rather than replacing them. By the time Egypt's first pyramids appeared, monument building already had a history measured in millennia, yet pyramids themselves emerged from specific cultural systems, not merely from the universal appeal of a rising shape. To understand Gunung Padang, the investigation must therefore avoid two opposite mistakes: denying what ancient communities could accomplish and granting them achievements that the surviving evidence does not demonstrate. Between those extremes lies the real archaeological task, following the stones, layers, and human traces from the visible summit into the uncertain history beneath it. From that broader world of early monuments, the path returns to the green ridges of West Java, where Gunung Padang did not first enter history as a pyramid. For local communities, the hill was already a place with meaning before geologists, government teams, television crews, or international headlines arrived. Its name is often translated in ways that evoke a mountain or field of light, and stories surrounding the summit connect it with ancestors, sacred gatherings, legendary rulers, and unfinished works from a distant past. Such traditions do not function as construction records, but they reveal something important. The site was never an empty landscape waiting for modern science to notice it. People had climbed its slopes, recognized the unusual stone arrangements, and treated the summit as a significant place long before the argument over its age began. Approaching the hill on foot helps explain why stories gathered there. The climb rises through cultivated land and tropical vegetation toward a summit that feels separated from the ordinary world below. Long volcanic stones appear in increasing numbers. Some stand upright or lean against one another. Others form lines, borders, low walls, and pathways. At the top, the terrain opens into a sequence of stepped terraces rather than a single flat platform. The higher one moves, the more deliberate the landscape appears. Natural columns have been rearranged into an architecture that is rough, but unmistakably organized. Even before formal excavation, the visible site suggested that communities had invested considerable effort in shaping the hilltop. Colonial-era observers and later Indonesian researchers recorded the presence of megalithic remains, but the site remained less internationally famous than the great temple complexes of Java. It did not offer towering carved facades like Borobudur or Prambanan. Its stones carried few obvious inscriptions, and its builders left no known royal account explaining why the terraces were made. The summit instead belonged to a wider family of Indonesian stepped megalithic sites often described as Punden Berundak. These places use ascending platforms to organize movement and ritual space. Their forms may reflect ideas about elevated sacred ground, ancestral presence, or the relationship between communities and mountains, although the evidence remains incomplete and no single explanation fully accounts for every site. For much of its documented history, Gunung Padang was understood primarily through what could be seen 5 principal terraces, stone arrangements, access routes, retaining features, and clusters of column-like rocks. Researchers measured the platforms and studied the way individual stones had been placed. The monument appeared important, but it was still largely a surface complex built on a natural hill. The transformation of Gunung Padang into a possible buried pyramid required a change in attention. Investigators had to stop looking only at the stones above ground and begin asking whether the hill itself concealed earlier construction. That shift came gradually. Reports of subsurface irregularities encouraged new surveys. The steep sides and roughly geometric profile of the hill invited comparisons with terraced monuments elsewhere. Photographs taken from elevated positions, satellite images, digital terrain models, and aerial views made the overall landform easier to imagine as a single object, seen from above or at a distance. Ridges and slopes could be traced into lines. Vegetation softened some irregularities and emphasized others. The summit terraces seemed to occupy the crown of a broader, tapering mass. To a viewer already searching for a pyramid, the hill could begin to look like one. Images, however, can be persuasive without being diagnostic. Natural hills often appear symmetrical from particular angles. Erosion follows fractures and rock layers, producing faces, steps, and ridges that resemble design. Vegetation can hide inconvenient contours while revealing the ones that support a geometric interpretation. Aerial imagery is invaluable for discovering roads, walls, mounds, field systems, and buried settlements, but shape alone cannot establish construction. A triangular outline does not show whether stone was quarried and laid in courses, whether slopes were cut into terraces, or whether the form results from volcanic processes acting over immense spans of time. Even so, the possibility of a buried structure attracted attention because the visible summit was unquestionably modified by people. If ancient builders had created terraces at the top, perhaps earlier builders had reshaped the slopes. If natural volcanic columns had been moved across the summit, perhaps similar stones beneath the surface had also been arranged. Each confirmed act of human construction made the next inference feel more plausible. The danger was subtle. Evidence for one part of the site could begin to lend authority to claims about another part that had not yet been demonstrated. Preliminary geophysical surveys added a new layer of intrigue. Ground-penetrating radar, electrical resistivity measurements, seismic methods, and other forms of subsurface imaging detected contrast within the hill. These techniques do not produce photographs of buried rooms. They measure differences in the way energy moves through soil and rock, a change in density, moisture, porosity, fracture pattern, or material composition may appear as an anomaly. Such anomalies can result from walls, cavities, trenches, or foundations, but they can also arise from natural cracks, lava structures, weathered zones, groundwater, or changes in sediment. At Gunung Padang, some readings were interpreted as evidence for layered construction and possible hollow spaces. The idea of a monument beneath the terraces began to gain a technical appearance. Maps showed coloured zones. Cross-sections suggested boundaries. Three-dimensional models gave the invisible hill an internal geometry. To non-specialists, These images could look almost like architectural scans, yet geophysical data remain indirect. They require testing through excavation, coring, and careful comparison with known geology. A strong anomaly tells investigators where something changes. It does not automatically explain what caused the change. Drill cores brought material from deeper levels to the surface. Soil, fragmented rock, and volcanic deposits could be examined and sampled. Trenches exposed sections of the upper layers. Researchers identified units they believed represented different phases of alteration or construction. The deepest proposed phase was described as a carefully shaped natural lava core. Above it, other layers were interpreted as arranged stone, fills, and later terraces. This model turned Gunung Padang into a monument built and rebuilt over astonishing lengths of time, with the visible megalithic summit representing only the most recent episode. The narrative was powerful because it combined several kinds of evidence that seemed to reinforce one another. The hill looked geometric from a distance. The summit contained real human stonework. Subsurface surveys detected anomalies. Core samples revealed layers. Radiocarbon tests produced ancient dates, placed together. These elements could be presented as a single discovery, a vast pyramid concealed beneath a later megalithic site. But each step depended on interpretation. A geometric hill might be natural. A geophysical anomaly might be geological. A deep layer might not be constructed. Ancient carbon might date soil rather than architecture. When uncertain observations are stacked together, they do not always become certainty. Sometimes they multiply the uncertainty. Public interest grew faster than the archaeological testing. The possibility of an Ice Age pyramid linked the site to a global appetite for lost civilizations. Gunung Padang was no longer merely an Indonesian megalithic complex. It became a challenge to conventional history, a place said to contain evidence that organized society had existed thousands of years earlier than accepted timelines allowed. Political interest, national pride, media competition, and genuine scientific curiosity all entered the same conversation. The hill became a symbol of what might lie hidden beneath familiar landscapes. This expansion of the story did not require fraud or a single deliberate invention. It emerged through a chain of increasingly bold interpretations. Local memory established antiquity and sacred importance. Visible terraces demonstrated human labor. Aerial perspectives suggested a larger form. Geophysical surveys implied buried complexity. Core samples offered physical depth. Radiocarbon measurements supplied dramatic numbers. At every stage, a cautious possibility could be shortened into a confident statement. What survives in the record suggests a site transformed twice, first by ancient communities who arranged the summit stones, and later by modern expectations that reshaped how the entire hill was seen. The discovery was not one sudden moment when a pyramid appeared beneath the earth. It was a gradual change in perspective, as a real megalithic monument became attached to a much larger hypothesis. To determine whether that hypothesis could survive, investigators needed to move beyond outlines, anomalies, and impressions. They had to test the buried material itself and ask whether the internal layers carried the unmistakable signatures of architecture. Once the invisible layers became the center of attention, the visible hill had to be read again with greater care. Gunung Padang is not a smooth artificial cone rising from a plain. It is a steep volcanic landform whose summit has been modified into a sequence of terraces. The distinction is easy to state and difficult to hold in the mind, because the upper monument and the natural hill beneath it overlap so completely. Every interpretation begins with the same object's long volcanic stones, stepped surfaces, retaining lines, narrow passages, sloping ground, and a summit that appears ordered. The disagreement begins with how much of that order belongs to human design. The most widely accepted human-made features are concentrated near the top. 5 principal terraces occupy the summit, each reached by ascending from the level below. The platforms vary in size and arrangement. Some are open, while others contain lines or clusters of stone that divide the space into smaller zones. Long columnar blocks lie side by side, stand at angles, or form low boundaries. In places, they create pathways or retaining edges. Their arrangement suggests more than random collapse. People selected stones, shifted them, and created spaces with practical or ceremonial purpose. The material itself contributes to the confusion. Many stones are naturally elongated because volcanic rock can fracture into columns as it cools. Similar formations occur in volcanic landscapes around the world, where repeated joints divide solid lava into strikingly regular shapes. These rocks can look manufactured even before anyone moves them. At Gunung Padang, ancient builders did not need to carve every block from shapeless stone. They could gather naturally formed columns and use them almost like ready-made beams. The result is an architecture whose basic components carry a geometric character inherited from geology. That inheritance matters because regular stone does not automatically indicate regular construction. A cluster of parallel blocks may be a wall, a collapsed arrangement, or exposed natural jointing. A line may mark a boundary, or it may follow the way the rock fractured beneath the soil. A flat surface may be a prepared terrace, or a naturally resistant layer revealed by erosion. Archaeologists must look for relationships whether stones were transported, whether they rest on prepared bedding, whether fills were placed behind retaining walls, whether surfaces show repeated use, and whether artifacts occur in undisturbed context associated with the construction. On the summit, some of those relationships are persuasive. The terraces are difficult to explain without human modification. Their organization directs movement upward. Stone alignments divide space in ways that seem purposeful. The site fits a broader Indonesian tradition of stepped megalithic places built on elevated terrain. This interpretation does not require the entire hill to be artificial. It describes a natural high point that people transformed into a monument by arranging its available stone. The pyramid interpretation extends that human order far beyond the summit. In this view, the visible terraces are the latest layer of a much older structure, while the slopes conceal earlier walls, fills, and chambers. The hill's overall form is treated as architectural rather than geological. Surface stones lower on the slopes may be interpreted as displaced masonry. Changes in slope become possible construction stages. Buried layers detected through drilling or geophysical survey are understood as separate building phases. The mountain becomes a monument assembled or reshaped over thousands of years. A third possibility lies between these extremes. Ancient communities may have altered more of the hill than the visible summit alone without constructing a pyramid from its base. They could have cut terraces into natural slopes, stabilized pathways, moved stone across selected areas, or reused older surfaces. Later communities may have rebuilt portions of the monument, leaving several phases of activity superimposed on a volcanic core. Such a history would be complex, but complexity is not the same as a buried pyramid. Human modification can spread across a landscape without turning the underlying landform into architecture. The word pyramid creates expectations that the evidence may not support. It suggests a designed mass with coherent sides, a planned base, and a recognizable relationship between exterior shape and internal structure. At Gunung Padang, no continuous casing. Regular course system. complete foundation, or securely demonstrated internal architectural plan has been exposed. These slopes are covered by soil, vegetation, fallen rock, and volcanic material. Their apparent symmetry changes with viewing angle. Some lines continue only briefly before disappearing into irregular ground. What looks like a face from one direction may merge into a natural ridge from another. Tombs have also entered popular speculation, largely because pyramids elsewhere are associated with burial. Yet no confirmed royal chamber, burial complex, or funerary assemblage has established Gunung Padang as a tomb. The visible terraces may have served ritual purposes, but ritual does not necessarily mean burial. Elevated ceremonial places can support gatherings, offerings, ancestor veneration, political display, or activities that leave only faint traces. Scholars still debate how the summit spaces were used, and the evidence remains incomplete. Possible cavities beneath the hill add another layer of ambiguity. A hollow reading can easily become a chamber in public retellings, but volcanic landforms frequently contain fractures, weathered zones, voids between blocks, and irregular spaces created by cooling or erosion. To call one of these a chamber requires more than evidence of low density or high resistivity. Investigators would need boundaries that behave like walls, an accessible entrance or passage, internal surfaces, construction material, or cultural deposits. Without such confirmation, the most accurate term remains anomaly or possible void. The terraces themselves also resist simple classification. They are often described as megalithic, but that term covers a wide range of practices rather than a single culture or date. Large stones can be arranged in very different periods by communities with unrelated beliefs. A stepped form may develop because a slope demands retaining walls, because elevation carries symbolic meaning, or because each generation adds a new level. Similar shapes do not prove shared origins. Carol, Saqqara, Mesoamerican platforms, Indonesian Punden Berundak, and natural terraced hills may all appear pyramid-like in photographs, while belonging to entirely different histories. This is why the landscape must be examined feature by feature. The upper terrace walls can be human-made even if the deeper slope is natural. A buried stone alignment can be genuine without belonging to the Ice Age. An ancient soil layer can lie beneath later construction without dating the first shaping of the hill. A natural volcanic formation can provide the core of a monument that later communities transformed. Archaeology rarely offers the clean choice between complete invention and complete nature that public debate prefers. There is also a psychological force at work. Once a viewer is told that a pyramid lies beneath the hill, every line begins to support the idea. Stones become blocks, fractures become passageways, terraces become construction phases, and cavities become chambers. The reverse can happen as well. A skeptic may dismiss every anomaly as geology and overlook real episodes of human modification. Both reactions begin with conclusions and force the landscape to obey them. What survives on the summit suggests sustained human intention. What lies beneath remains much less certain. Gunung Padang may be a ceremonial complex built upon a natural volcanic hill, a landscape modified in several stages, or a site with buried features not yet fully understood. The evidence does not currently justify calling the entire formation a confirmed pyramid, but neither does it reduce the place to an accidental pile of stone. The monument exists in the boundary between geology and culture, where natural form gave ancient builders material, elevation, and perhaps meaning. To move beyond competing impressions, researchers turned to instruments designed to see through the ground. hoping that the buried patterns would reveal whether the hill contained architecture or only the complicated anatomy of a volcano. The hope behind subsurface survey is simple. If a monument lies buried inside a hill, instruments should be able to detect the contrast between architecture and geology. Walls should differ from soil. Voids should interrupt solid rock. Foundations should create regular boundaries. Filled chambers should preserve shapes unlike the surrounding volcanic mass. In practice, the underground world is rarely so cooperative. The methods used at Gunung Padang do not reveal a hidden building in the way a camera reveals a room. They measure physical properties, translate those measurements into patterns, and leave researchers with the difficult task of deciding what those patterns mean. Ground-penetrating radar sends electromagnetic pulses into the Earth and records the energy reflected when the signal encounters a boundary, a buried wall, a change in sediment, a large stone, a fracture, a pocket of moisture, or the surface of bedrock can all produce reflections. Under favourable conditions, radar can map graves, floors, foundations, tunnels, and buried roads with impressive clarity. But tropical soils, clay, water, rough terrain, and fractured volcanic rock can weaken or scatter the signal. The resulting profiles may contain arcs, bands, bright zones, and interruptions that require experienced interpretation. A reflection can show that something changes at a particular depth. It cannot announce whether the cause is a wall, a boulder, or a natural crack. At Gunung Padang, radar results were used to identify zones that appeared different from the surrounding hill. Some were described as structural layers, while others were interpreted as possible cavities. These readings became central to the idea that the summit terraces continued downward into a much larger monument. Yet the same data can support several models. Closely spaced stones might represent deliberate packing, a collapsed terrace, or natural columnar rock. A strong horizontal reflector might be a prepared surface, but it might also mark a weathered geological boundary. A low response zone could indicate open space, loose fill, saturated soil, or highly fractured material. Electrical resistivity surveys approach the problem differently. Investigators place electrodes in the ground and measure how strongly the subsurface resists the flow of electrical current. Dry stone, wet soil, clay, open cavities, and fractured rock may produce contrasting values. By taking many measurements across a grid, researchers can create two-dimensional sections or three-dimensional models of electrical variation beneath the site. The images are often displayed in vivid colours, with red, yellow, green, and blue regions suggesting different resistivity ranges. To the untrained eye, these coloured forms can resemble solid objects inside the hill. They are not objects. They are mathematical reconstructions based on measurements taken from the surface. A high resistivity anomaly might indicate dense dry stone or an air-filled void. It might also reflect naturally jointed volcanic material above the water table. A low resistivity zone could be damp fill, clay-rich sediment, or weathered rock. The method is valuable because it allows investigators to compare broad internal patterns across areas too large to excavate. Its weakness is that different materials can produce similar signals. Interpretation improves when resistivity is tested against exposed geology, drill cores, and known archaeological features. Without that calibration, an anomaly remains a promising target rather than a confirmed room or wall. Seismic tomography adds another perspective. It measures how waves move through the ground. Dense, intact rock usually transmits seismic energy differently from loose sediment, fractured zones, or cavities. Sensors record the travel times of vibrations generated at the surface, and computer models estimate the distribution of faster and slower material below. In engineering, such methods can help locate faults, unstable ground, tunnels, or buried structures. On a volcanic hill, however, they encounter a naturally complicated interior. Cooling fractures, lava contacts, weathered zones, and variable deposits can all create sharp contrasts without human involvement. The strength of using several techniques is that independent measurements can be compared. If radar, resistivity, and seismic surveys all identify an anomaly in roughly the same place, confidence grows that a real physical difference exists there. But agreement does not automatically identify the cause. 3 methods can detect the same natural fracture system. They can confirm that a zone is unusual while leaving its origin unresolved. The crucial next step is direct investigation. Drilling offers a narrow path into the hill. A core can bring up a vertical sequence of soil, stone fragments, weathered material, and denser rock from selected locations. Researchers can examine texture, mineral composition, particle size, orientation, and signs of disturbance. They can collect organic material for radiocarbon dating. They may identify gaps where the drill passes through a void, or zones of loose fill that differ from surrounding bedrock. Yet a core is only a thin sample through a large and uneven landform. Several meters away, the sequence may change completely. A drilled column cannot reveal the plan of a wall or room unless many cores are carefully correlated. The interpretation of cores at Gunung Padang became one of the most contested parts of the investigation. Some layers were described as deliberately arranged stone or artificial fill. Others were treated as modified natural lava. The proposed sequence suggested repeated construction episodes, each burying or reshaping what came before. But critics argued that broken volcanic rock, weathered material, and naturally deposited soil could produce similar core patterns. To establish construction, researchers would need to demonstrate organization beyond the narrow borehole consistent stone orientation, prepared surfaces, imported fill, tool marks, cultural debris, or boundaries that continue across space. Excavation is the method that can most directly test such interpretations, but it is also the most destructive and labor-intensive. A trench removes soil layer by layer, exposing relationships that instruments only suggest. Archaeologists can observe whether stones form a wall, whether one feature cuts another, whether a surface was prepared, and whether artifacts lie sealed within a particular phase. They can document the exact position of charcoal, pottery, tools, bones, and other remains before those relationships are disturbed. At a steep, protected, and culturally important site, excavation must also be limited and cautious. No responsible team can strip away an entire hill simply to see whether a geometric model is correct. The trenches opened at Gunung Padang confirmed human activity near the upper monument and exposed complicated deposits. They did not reveal a continuous artificial pyramid extending through the hill, nor did they establish a clear architectural connection between the deepest radiocarbon samples and a human-built structure. This gap became increasingly important. Geophysical surveys had suggested internal complexity, but excavation had not yet converted that complexity into unmistakable architecture. A genuine buried wall should behave like a wall across several kinds of evidence. It should have edges, thickness, construction logic, and relationships with adjacent deposits. Its stones may be selected or oriented. Sediment behind it may differ from sediment in front of it. A floor may meet its base. Artifacts or organic remains may be sealed during construction or use. A chamber should have boundaries, and an internal space distinct from natural fractures. A passage should lead somewhere and show continuity. Without these features, words such as wall, chamber, or corridor risk becoming interpretations disguised as observations. This is the central limitation of remote sensing in archaeology. The instruments are excellent at finding places where the subsurface changes. They are less capable of determining why. Their results are strongest when investigators begin with multiple possible explanations and design excavations to distinguish among them. They become dangerous when every anomaly is translated into the most dramatic architectural term available. At Gunung Padang, the surveys did reveal that the hill is internally varied. That finding is real and potentially important. Volcanic hills are complex, and ancient communities may have modified more of the summit and slopes than is currently visible. Buried terraces, fills, pathways, or earlier ceremonial surfaces may still await discovery. Scholars still debate the meaning of several anomalies, and the evidence remains incomplete. But subsurface complexity is not the same as proof of a pyramid. The instruments created a map of possibilities beneath the forested summit. They showed where stone, soil, moisture, density, or fracture patterns changed. They guided drilling and excavation towards selected targets. What they did not provide was a direct image of an Ice Age monument. That conclusion depended on another step assigning human purpose and extraordinary age to the buried layers. Once radiocarbon measurements entered the argument, the coloured anomalies and narrow drill cores seemed to acquire dates. The question then shifted from what lay inside the hill to whether the samples used to date it were connected to construction at all. A date can appear to settle an argument because numbers seem harder than interpretation. A laboratory result may place a sample within a range of years, calibrated against changes in atmospheric carbon and expressed with statistical precision. Once such a number enters a debate, it can overshadow everything around it. At Gunung Padang, the deepest radiocarbon dates carried this authority into public discussion. If organic material from far below the summit was tens of thousands of years old, then the buried structure seemed equally ancient. The logic felt direct. The sample came from inside the hill. The hill was said to contain architecture. Therefore, the date appeared to belong to the architecture. Yet that final step was precisely what had not been securely demonstrated. Radiocarbon dating measures the decay of carbon-14 in once living material. Charcoal, wood, seeds, bone collagen, fibers, shell, and other organic remains may preserve enough carbon to estimate when the organism stopped exchanging carbon with its environment. The method has transformed archaeology because it allows researchers to build chronologies independent of written records. But it dates the sample, not the surrounding idea. A charcoal fragment can be old while the wall beside it is younger. Soil can contain organic material from several periods. A root may penetrate an earlier deposit. Ancient carbon may be moved downhill, washed into a crack, redeposited in fill, or preserved in natural sediment long before people modify the ground above it. This is why archaeological context is as important as the laboratory measurement. A sample recovered from mortar that was mixed during construction may help date a wall, although even mortar presents technical difficulties. Charcoal sealed beneath a prepared floor may provide a date before which the floor could not have been laid. Short-lived seeds from a hearth sitting directly on a surface may closely reflect the time that surface was used. A wooden beam still fixed within a structure may date the tree's growth and, with suitable caution, the building phase. In each case, the physical relationship between sample and human activity is documented in the ground. The oldest Gunung Padang samples did not possess that kind of secure connection. They came from deep soil encountered through drilling and were interpreted within a model that treated surrounding layers as construction phases. The radiocarbon results established that organic material within those deposits was ancient. They did not independently establish that the deposits were walls, floors, fills, or chambers created by people. If the layers were natural volcanic formations containing old soil, the dates would describe environmental history rather than architecture. This distinction can be illustrated by imagining an ancient tree growing on a hillside. The tree dies, decays, and contributes carbon to the soil. Thousands of years later, people build a terrace higher up the slope or rearrange stones on the summit. A drill passes through the later monument and reaches the older soil below. The laboratory returns a very ancient date. Nothing about the measurement is necessarily wrong. The mistake occurs only if the age of the buried organic matter is assigned to the later human construction, without evidence that the sample was deposited during building. A similar problem arises with what archaeologists call residual material. Builders often move older earth. When a trench is dug, soil from earlier deposits may be thrown into a foundation fill. When a terrace is levelled, sediment containing ancient charcoal can be shifted from one place to another. The oldest object in a deposit therefore does not always date the event that created the deposit. A fragment of 10,000-year-old charcoal could be incorporated into a wall built thousands of years later. Archaeologists look for multiple samples, stratigraphic consistency, short-lived materials, and clear associations to reduce this risk. At Gunung Padang, the age model became especially vulnerable because the status of the surrounding formations was already disputed. The reasoning risked becoming circular. The layer was considered artificial partly because it fit a proposed construction sequence. The ancient carbon within it was then used to date that supposed construction. The dramatic date, in turn, was presented as support for the idea of a deep human-made layer. But if the initial classification of the layer was uncertain, the date could not resolve the uncertainty by itself. The withdrawn 2023 study proposed several phases extending from the visible megalithic terraces down into much earlier periods. The youngest upper phase was placed in later prehistory, while deeper units were assigned to increasingly remote dates, some reaching into the last ice age. This sequence gave the hill a story of repeated building across extraordinary spans of time. It suggested that later communities had inherited and modified a monument whose earliest creators lived before settled agriculture was widespread. Such a chronology would require more than old soil. It would require secure cultural material at each proposed phase, stone tools associated with construction, chipped fragments from shaping blocks, occupation surfaces, hearths, plant remains from meals, residues from binding materials, human-made cuts in bedrock, transported stone distinct from local geology, or patterns of repeated placement could all support the argument. Not every monument preserves every category of evidence, and tropical conditions can destroy organic remains quickly. Even so, a project of the proposed scale should leave some coherent archaeological signature beyond geophysical contrast and radiocarbon dates from sediment. Critics focused on this absence. The dates were not tied firmly to artifacts, prepared floors, mortar, post holes, or unmistakable construction. The surrounding deposits had not been proven artificial independently of the dates. The scientific problem was therefore not that radiocarbon dating had failed. It was that the historical event being dated had not been securely identified. In March 2024, the journal formally withdrew the study. The retraction statement emphasized that the dated soil samples lacked reliable association with evidence of human activity, or with structures established as anthropogenic. Without that connection, the dates could not support claims that a pyramid had been constructed 9,000 years ago or earlier. The authors disagreed with the decision, and withdrawal did not settle every question about the site. It did, however, remove the paper's extraordinary chronology from the body of evidence that could be cited as an accepted scientific result. The episode reveals a lesser-known truth about archaeological dating. Precision can create an illusion of certainty. A calibrated range may be statistically refined, yet its interpretation can remain fundamentally weak. A measurement can be accurate while the question attached to it is wrong. Science depends not only on obtaining numbers, but on proving what those numbers belong to. Even secure dates rarely speak alone. Researchers build chronologies from groups of samples, stratigraphic sequences, artifact types, construction relationships, and independent environmental evidence. A date that contradicts everything around it is not automatically revolutionary. It may identify contamination, redeposition, an old wood effect, a reservoir effect, or a mistaken association. Extraordinary antiquity is possible, but the older and more disruptive the claim, the more important it becomes to demonstrate the chain-linking sample, layer, human action, and monument. The comparison with clearly established early sites makes the problem sharper. At Göbekli Tepe, radiocarbon results are supported by carved pillars, quarrying, prepared floors, stoneworking debris, and recognizable architectural plans. The age does not depend on assuming that a natural hill is a building. At early settlements, hearths, walls, burials, tools, and repeated occupation create an archaeological context within which dates can be interpreted. Gunung Padang's deepest proposed phases lacked a similarly secure network of evidence. None of this means the lower layers contain no human history. Older surfaces may survive beneath later terraces. People may have visited the hill long before its visible stone complex was created. Soil can preserve traces of burning, vegetation change, or intermittent activity that future research may identify more clearly. But evidence for an ancient presence is not the same as evidence for an ancient pyramid. A person can stand on a hill without constructing the hill. By the time the controversy reached its peak, the numbers 16,000, 25,000, and 27,000 had become detached from the conditions that produced them. They circulated as ages of the monument rather than ages of organic material from disputed deposits. This transformation was small in wording and enormous in consequence. It turned a question about stratigraphic association into a declaration that civilization had begun far earlier than accepted history allowed. The dangerous question was never whether the radiocarbon samples were genuinely ancient. It was whether they dated a human construction. Until that relationship can be demonstrated through clear archaeological context, the deepest dates belong to the material sampled, not to a confirmed pyramid. The hill may preserve old carbon, old geology, and perhaps old episodes of human presence. What it does not yet preserve is a securely dated architectural sequence extending back into the Ice Age. To decide whether such a sequence ever existed, investigators must first answer an even more basic question: what physical evidence would distinguish deliberate construction from the natural architecture of volcanic stone? A human-built structure does not become recognizable because one stone looks straight, or because a buried layer appears unusually dense. Architecture is identified through relationships. Stones are selected, moved, aligned, supported, cut, stacked, or placed against prepared surfaces. Construction leaves sequences. A foundation comes before a wall meets a floor. Fill accumulates behind a retaining face. A passage connects spaces. Tools leave marks. Workers leave waste. Fires, meals, repairs, and repeated use alter the ground around the building. Even when most of the monument has collapsed, these relationships can survive as a pattern that natural processes rarely reproduce in the same way. The distinction is especially important at Gunung Padang because nature has already provided materials that resemble architecture. Columnar volcanic rocks can be long, angular, and relatively uniform. Cooling fractures divide lava into repeated forms. Weathering separates those columns. Gravity pulls them down slope, and soil fills the gaps. From a trench wall or narrow drill core, a natural accumulation of broken columns may look like deliberate packing. When geophysical instruments detect a dense band, it may resemble a buried wall before anyone has exposed enough of it to know whether it possesses the organization of one. Archaeologists therefore begin by asking whether the stone is in its natural geological position. A volcanic column still joined to its parent formation tells a different story from one transported several hundred meters and laid across the direction of the original rock joints. A block resting at an unnatural angle may have been moved, though landslides can also rotate stone. A single displaced column proves little. Hundreds arranged consistently across a level surface present a stronger case. The pattern matters more than the isolated object. Transport is one of the clearest signs of human action. If a stone type does not occur naturally where it is found, someone or something carried it there. At many monuments, builders selected material from specific quarries, leaving extraction scars, unfinished blocks, transport routes, and fragments produced during shaping. At Gunung Padang, much of the visible stone derives from local volcanic formations. This does not weaken the reality of the summit construction. Ancient builders often used the nearest suitable material. It does mean that researchers must distinguish stone deliberately moved from stone exposed where geology placed it. Orientation can provide another clue. Builders tend to place stones according to structural need. Blocks in a retaining wall may present stable faces outward and extend back into the fill. Paving stones may lie flat beneath a walking surface. Upright markers may be wedged into pits. Parallel courses may maintain a consistent direction across a terrace. Nature also creates alignment through bedding, jointing, slope movement, and water flow. But natural patterns usually reflect geological forces rather than the demands of a designed space. The challenge is to show that the arrangement solves an architectural problem. At the summit, low walls and terrace boundaries appear to do exactly that. They organize elevation and movement. They help define platforms. Some stone lines follow the edges of usable spaces rather than simply continuing the natural fracture pattern of the hill. These visible features support the accepted interpretation that people modified the summit. Yet the same standard must be applied to the buried layers. If a supposed deep wall is claimed, investigators should be able to trace its direction, thickness, base, and relationship to neighbouring deposits. A dense zone detected by instruments is not enough. A core containing several stones is not enough. The feature must behave like construction when examined across space. Foundations are equally revealing. Large monuments usually require preparation. Builders may cut into bedrock, level a surface, dig trenches, or lay a course of smaller stones beneath heavier blocks. The boundary between foundation and natural ground can preserve tool marks, compacted sediment, or fill placed to correct an uneven surface. At Egyptian pyramids, quarrying and levelling are visible. At Neolithic enclosures, pillars stand in prepared sockets, at terrace sites, retaining walls often hold deliberately deposited fill. No universal foundation style exists, but architecture usually creates an interface where human intention meets the original landscape. At Gunung Padang, no continuous foundation has been exposed that defines the base of a giant artificial pyramid. The absence does not prove that every buried feature is natural, because only limited areas have been excavated. It does mean that the larger claim lacks one of the most important forms of confirmation. If the entire hill were built or comprehensively reshaped, researchers would expect some consistent boundary between natural volcanic formation and constructed mass. Scholars still debate whether such a boundary exists, and the evidence remains incomplete. Tool marks can strengthen the case for human workmanship, though they are not always preserved. Hammering, pecking, grinding, cutting, and splitting leave characteristic scars. Builders using naturally formed columns may need little shaping, but sockets, joints, doorways, or fitted surfaces often require modification. Broken waste can accumulate nearby. Repeated blows produce flakes and fragments whose distribution may reveal a working area. Gunung Padang's upper stones show selection and placement more clearly than extensive carving. For the proposed deep phases, securely identified ancient tool marks remain scarce. Binding materials would be another powerful clue. Mortar, clay packing, plaster, or prepared earth can link stones into a structure and may contain material suitable for dating. Yet no confirmed Ice Age mortar has established the age of Gunung Padang's deeper formations. Claims about cement-like substances or artificial fills require chemical and microscopic analysis, capable of separating human mixtures from naturally weathered volcanic material. A strange composition is not automatically a construction product. Geological alteration can create minerals and textures that appear manufactured unless compared with local natural deposits. Cultural debris provides the surrounding human context that a massive building project should generate. Stone tools break, food is prepared, fires leave ash and charcoal, workers discard fragments, paths become compacted, water is managed. Temporary shelters or gathering areas form nearby. A monument may be cleaned carefully, and tropical conditions can destroy much of the evidence, but large and repeated construction generally leaves more than the monument itself. At securely dated sites, artifacts and occupation traces help connect architecture to the people who built and used it. This is one of the deepest difficulties facing the Ice Age interpretation of Gunung Padang. The proposed construction scale is enormous, yet the associated cultural assemblage is thin. No securely documented collection of Ice Age tools, workshops, living surfaces, or construction debris has been tied to the deepest alleged architectural phases. The absence is not absolute proof that the phases never existed. Archaeological survival is uneven, and limited excavation can miss important deposits. But an extraordinary claim cannot rely indefinitely on the hope that all confirming evidence remains just beyond the exposed area. Spatial repetition is also essential. A human design should continue in understandable ways. A wall should extend beyond a single trench. A floor should occupy a surface. A chamber should have limits. A passage should maintain direction. If repeated excavations encounter the same arrangement at predicted locations, confidence increases. If the feature dissolves into irregular fractured rock, the architectural interpretation weakens. This is why broad exposure, careful mapping, and independent testing matter more than a dramatic image from one profile. Natural formations can be astonishingly deceptive. Basalt columns resemble stacked blocks. Lava tubes resemble tunnels. Cooling cavities resemble chambers. Erosion creates steps. Landslides produce mixed deposits that look like fill. Roots disturb layers. water sorts stones into bands. Mineral growth can resemble mortar. Humans are skilled at detecting order, but that skill often causes patterns to appear where no design exists. Archaeology must therefore demonstrate not merely regularity, but regularity connected to human behavior. The reverse mistake is also possible. Natural materials may be incorporated into genuine architecture so subtly that researchers underestimate human modification. A community can use an existing ridge as a platform, deepen natural steps, stabilize a slope, arrange local columns, and create ceremonial spaces without constructing a freestanding building. Gunung Padang may preserve precisely this kind of partnership between geology and culture. The hill could be predominantly natural while carrying several episodes of deliberate alteration. What counts as human construction is therefore not decided by whether the site looks impressive, mysterious, or geometrically suggestive. It is decided by converging evidence, displacement, orientation, foundations, prepared surfaces, tool traces, cultural deposits, repeated patterns, and secure stratigraphic relationships. The summit terraces satisfy enough of these tests to be recognized as a real megalithic complex. The proposed deep pyramid has not yet done so. That difference does not close the investigation. It defines what future work must find. A securely excavated wall continuing across several trenches, a prepared floor sealed beneath later terraces, tools associated directly with construction, or dated organic material embedded within an unmistakably artificial feature, could transform the debate. Until then, the deepest layers remain geological formations and possible modifications rather than confirmed architecture. The burden is not to prove that ancient people were capable of building. Their capabilities are already beyond doubt. The burden is to show that, beneath this particular hill, they actually did. If people did reshape the deeper parts of Gunung Padang, the proposed dates would place some of that work in a world profoundly different from the one that produced the visible summit terraces. 20,000 years ago, sea levels were far lower, climates were cooler, and the geography of Southeast Asia had been transformed by the last glacial period. Java, Sumatra, Borneo, and the Asian mainland were connected across a vast region of exposed land known as Sunderland. Forests, grasslands, rivers, wetlands, and mountain corridors stretched across areas now covered by the Java Sea and South China Sea. Human groups moved through this changing landscape without knowing that rising oceans would later divide it into islands. The people of this world were not crude figures waiting for civilization to begin. Modern humans had lived in Southeast Asia for tens of thousands of years. They understood local stone, wood, plants, animals, rivers, seasons, and terrain with a precision that rarely survives archaeologically. They made tools from materials that could be carried, sharpened, repaired, and replaced. They crossed difficult landscapes and, in some regions, substantial bodies of water. Their communities maintained social ties across distance, shared knowledge, and adapted to environments ranging from tropical lowlands to upland forests. What the evidence does not show is an Ice Age society in West Java constructing a stone pyramid on the scale proposed for Gunung Padang. No known settlement, quarry, workshop, tool assemblage, or ceremonial landscape from the region securely demonstrates that level of building. This absence does not make such construction physically impossible. It makes it archaeologically unsupported. Possibility and evidence remain separate. The summit itself would have offered practical and symbolic attractions in almost any period. High places provide broad views, cooler air, defensible approaches, and a sense of separation from the surrounding lowlands. A prominent hill can serve as a landmark for people moving through forests where visibility is otherwise limited. It may mark territory, guide travel, or become associated with ancestors and powerful natural forces. Mountains frequently gather sacred meaning because they seem to connect earth, sky, weather, and the hidden interior of the land. The volcanic stone would also have been useful. Columnar rocks break into manageable lengths and can be moved with levers, ropes, wooden rollers, sledges, or coordinated lifting. No metal tools are required to rearrange naturally fractured blocks. A determined group could clear vegetation, expose stone, drag columns uphill or across the summit, and build retaining lines. The work would be exhausting, but prehistoric communities repeatedly accomplished demanding tasks through collective labor. The scale of cooperation matters more than the weight of any single block. A small group can move a surprisingly heavy stone when the route is prepared and the work is divided. Larger projects require food, planning, leadership, and a reason for people to return. That reason need not involve kings or permanent armies. Ceremonies, seasonal gatherings, marriage networks, ancestor rites, alliance building, and communal feasts can mobilize labor. Monument building may strengthen social bonds even when no centralized state exists. Göbekli Tepe demonstrates that early communities could erect monumental structures before cities and mature agriculture, but the builders there left a dense archaeological record: carved pillars, quarry zones, stone debris, prepared floors, buildings, and associated material. The lesson is not that any ancient community anywhere could therefore have constructed any monument imaginable. The lesson is that social complexity can take forms that archaeologists once underestimated, provided the material evidence supports the claim. If Gunung Padang's deepest proposed phase truly dated to the last ice age, its builders would have lived during a time when most communities in the region were mobile or only intermittently settled. A project involving the reshaping of an entire hill would imply repeated access to food, organized labor, technical knowledge, and a durable social reason to maintain the site. Such a community might not resemble an urban civilization, but it would leave traces of activity around the monument: camps, hearths, tool-making debris, food remains, pathways, or nearby extraction areas should survive somewhere, even if preservation were poor. Tropical archaeology presents serious difficulties. Acidic soils can dissolve bone. Heat and moisture destroy wood, fibers, and plant remains. Dense vegetation hides surface features. Erosion moves sediment downslope. Later construction can disturb earlier deposits. Volcanic activity and earthquakes may alter landscapes beyond recognition. A thin archaeological record is therefore not surprising. Yet poor preservation cannot be used as a universal explanation for every missing category of evidence. It is a limitation to be measured, not a substitute for confirmation. During the late Ice Age, the region's environment also changed repeatedly. Cooler conditions did not mean West Java became a frozen landscape. Tropical vegetation persisted, though forest distributions, rainfall patterns, and elevation zones shifted. People could move between uplands and lowlands, exploiting different resources across the year. As the climate warmed after the glacial maximum, sea levels rose and flooded Sunderland. Rivers changed course. Coastlines retreated. Populations became separated across newly forming islands. These transformations would have reshaped travel, exchange, and settlement. A prominent upland site might have gained importance during such change. Communities could have returned to it as a stable landmark while surrounding lowlands transformed. The hill may have accumulated meaning gradually rather than through one enormous construction project. Early visitors might have used natural clearings or placed a few stones. Later groups could have enlarged terraces, rebuilt walls, and reorganized ritual spaces. Over centuries, the summit might become increasingly formal while preserving memories of earlier use. This kind of cumulative development is common in sacred landscapes. A place does not need to begin as a complete monument. One generation marks it, another adds a boundary. Later communities rebuild, reinterpret, and claim connection with those who came before. Eventually, the natural hill and the human structure become inseparable. Such a process could explain multiple phases at Gunung Padang without requiring an Ice Age pyramid hidden inside the volcano. The challenge is dating each phase. The visible terraces may have been repaired or rearranged repeatedly. Stones can be reused, leaving older material inside younger structures. Later communities may disturb earlier surfaces. A radiocarbon date from beneath a terrace might indicate activity before construction, sediment incorporated during building, or natural soil preserved under the monument. Only careful stratigraphy can distinguish these possibilities. Imagining the builders must therefore remain disciplined. They were capable people, not primitive stereotypes. They knew how to cooperate and how to work with stone. They may have attached ceremonial meaning to elevated places. They may have occupied or visited the hill earlier than the best documented summit construction. None of these reasonable possibilities proves that they engineered a vast pyramid. The strongest reconstruction begins with the evidence that survives. At some point, communities carried and arranged volcanic columns across the summit. They created stepped spaces and maintained a place important enough to demand substantial effort. Their exact identity is uncertain because the site has not produced inscriptions or a clearly defined cultural assemblage that names them. The terraces may belong to more than one period, and scholars still debate their chronology and function. If earlier people stood on the same summit, they may have seen a world now lost beneath the sea. The horizon would have opened toward river plains and distant lands that no longer exist. Their paths, camps, and coastlines have largely disappeared, leaving only fragments of stone and buried soil. That vanished geography makes the idea of forgotten cultures emotionally compelling. Entire landscapes truly did drown as the Ice Age ended. But drowned landscapes and capable foragers do not confirm a buried pyramid. They create a plausible human world in which meaningful construction could occur, while leaving the particular claim at Gunung Padang unresolved. The possible builders were neither incapable nor all-powerful. They lived within the limits of available food, tools, labour, and social organisation, and their activities should be sought in the traces those limits produced. The question is not whether prehistoric people deserve credit for complexity. They do. It is whether the complexity imagined beneath Gunung Padang matches the archaeological record of the people who would have had to create it. To answer that, the hill must be compared with the early monuments whose builders are equally ancient, but whose construction is far more securely demonstrated. The comparison begins with a correction to an old assumption. For much of modern archaeology, large monuments were treated as the products of settled farmers, surplus food, political hierarchy, and permanent leadership. The logic seemed obvious. People who moved often could not accumulate enough material. Communities without agriculture could not feed large workforces. Societies without kings could not coordinate labour across many seasons. Monumentality appeared to belong naturally to villages, then towns, then states. Discoveries from the early Holocene have made that sequence far less secure. Göbekli Tepe is the most famous example because its monumental enclosures were created by communities living near the transition between mobile foraging and settled food production. Beginning around the 10th millennium BCE, builders quarried large limestone pillars, shaped them into distinctive T-forms, carved animals and human features onto their surfaces, and arranged them within circular or oval structures. Some pillars weighed several tons. Central pairs dominated the interiors, while smaller pillars stood around the perimeter. Floors were prepared, walls were built, and older enclosures were eventually filled before new ones appeared nearby. Nothing about this construction is vague. Quarry scars survive. Unfinished pillars remain in the bedrock. Stoneworking debris connects extraction to shaping. Pillars stand in sockets and follow architectural plans. Radiocarbon dates belong to deposits associated with the buildings, rather than simply to ancient soil somewhere below the site. Scholars still debate exactly who gathered there, how permanently they lived nearby, and what the carved imagery meant. But the human origin of the structures is unmistakable. That certainty changes the question surrounding Gunung Padang. No one can dismiss an early date merely by saying that foragers were incapable of organized construction. The archaeological record now shows that communities without cities, writing, or dynastic rulers could gather labor and build on a monumental scale. Yet Göbekli Tepe also demonstrates how much evidence a secure claim requires. Its age is surprising because the architecture is clear, not because ancient carbon was found beneath a natural hill. Other sites reinforce the point, at Karahantepe and related locations across southeastern Anatolia. Early communities created stone buildings, carved figures, benches, pillars, and ritual spaces. In the Levant, settlements such as Jericho included substantial stone construction, including a massive tower whose function remains uncertain. These places were not identical, and they should not be merged into a single civilization. They reveal a broader pattern in which early communities experimented with permanence, gathering, memory, and built space before the rise of the first states. The labor behind these monuments may have been organized through seasonal aggregation. Groups dispersed across a landscape could gather at particular times when food was abundant. Hunting seasons, plant harvests, marriages, exchange, ritual obligations, and communal feasting may have brought people together. Construction could occur during these periods, turning cooperation into stone. The monument then became a reason to return, strengthening networks that had helped build it. This model does not require a king issuing commands. Authority may have been temporary, ritual, negotiated, or distributed among households. Skilled stoneworkers could direct particular tasks without ruling the wider community. Feasting could reward labor and display generosity. Participation might create obligations between groups. A monument could embody shared ancestry, or territorial claims while also serving practical social purposes. The work itself may have helped produce the community that later generations assumed had always existed. Such possibilities are relevant to Gunung Padang because a stepped summit complex could have been created through repeated episodes rather than one centralized campaign. Communities might gather, move a limited number of stones, repair a terrace, or add a new boundary. Over generations, these additions could produce a large monument without the administrative machinery associated with Egypt. The visible site does not require a state to explain it. The deeper pyramid hypothesis demands something more. It proposes not merely a ceremonial terrace modified over time, but a large internal structure built through several phases extending far into prehistory. If the deepest phase truly belonged to the Ice Age, then the scale and continuity of construction would exceed what is currently documented in the regional archaeological record. That does not make it impossible, but it raises the evidentiary standard. A comparison with the Göbekli Tepe reveals several missing links. At the Anatolian site, architecture can be followed from quarry to finished building. At Gunung Padang, no comparable quarry sequence has been tied securely to the deepest proposed phases. At Göbekli Tepe, carved pillars and prepared floors identify designed spaces. At Gunung Padang, the supposed deep structures remain largely geophysical anomalies and disputed stone layers. At Göbekli Tepe, cultural deposits surround the buildings. At Gunung Padang, a matching Ice Age assemblage has not been securely demonstrated. The contrast is not a contest over which site is more impressive. It is a lesson in archaeological reasoning. An established early monument does not make every other early monument claim more likely in equal measure. It shows what kinds of evidence can overcome previous expectations. When many independent lines converge, archaeology changes. When the evidence depends on one uncertain association, caution remains necessary. There is also a difference between building a monument and reshaping an entire landform. Early communities could quarry pillars, construct walls, and create enclosed spaces without moving the mass of a hill. A natural summit offers an easier path to monumentality. Builders can use elevation already provided by geology, adding terraces and stone arrangements where they have the greatest visual and ritual effect. Gunung Padang may represent this efficient strategy, not creating a mountain, but turning a mountain into a meaningful place. That distinction often disappears in popular retellings. The claim that foragers could build monuments becomes the claim that they could build Gunung Padang's entire buried pyramid. The first statement is supported by evidence from several regions. The second remains unproven at this particular site. Human capability establishes possibility, not occurrence. Caral Soup in Peru offers another useful comparison, though it is much later than Göbekli Tepe. Around 5,000 years ago, communities in the Soup Valley created large platform mounds, plazas, residential areas, and ceremonial buildings. Some structures appear pyramid-like because of their stepped mass. Yet their archaeological identity comes from exposed architecture, construction fills, organized settlements, activity areas, and a broader cultural landscape. The monuments did not become credible because they resembled Egyptian pyramids. They became credible because their building histories could be excavated. Across many parts of the world, people independently discovered that elevated platforms and stepped forms carry practical and symbolic power. A broad base supports height, terraces stabilize slopes, raised structures increase visibility, and separate ceremonial space from ordinary ground. Mountains already possess these qualities, so modifying a hill can create a monument with less labor than constructing one from nothing. Similar shapes can emerge without contact or shared origin, because builders face similar physical problems and human communities repeatedly attach meaning to height. Gunung Padang fits comfortably within that global pattern at the level of its visible terraces. Ancient people took naturally formed volcanic stone and created an ascending ceremonial landscape. The site is impressive precisely because it shows how communities worked with what geology provided. The need to turn it into the oldest pyramid may say more about modern expectations than about the builders themselves. There is a strange irony in the debate. Efforts to glorify ancient people can end up erasing their real achievements. If the summit matters only as the upper surface of a hidden Ice Age superstructure, then the documented megalithic terraces become almost disappointing. Their actual builders disappear behind hypothetical ancestors. Their regional traditions are replaced by a global lost civilization. Their careful use of local stone is overshadowed by claims about impossible engineering. A more grounded interpretation does not diminish prehistoric intelligence. It recognizes that monumentality takes many forms. A community can transform a summit without building a pyramid. A sacred place can accumulate over centuries without belonging to a forgotten empire. People can organize complex labor without kings, and they can create powerful architecture without leaving written names. What survives at securely dated early sites proves that foragers and early farmers were capable of remarkable construction. It also proves that such claims can be demonstrated when quarrying. Architecture, artifacts, stratigraphy, and dating align. Gunung Padang has not yet reached that level for its deepest layers. Its visible monument belongs in the history of human cooperation. Its buried pyramid remains a hypothesis. Between those two statements lies the difference between expanding the past and imagining it. The word pyramid does more than describe a shape. It carries Egypt with it. It brings to mind polished limestone faces, planned chambers, royal burials, precise alignments, and a civilization able to mobilize thousands of workers. Once that word is applied to Gunung Padang, the comparison begins before the evidence is examined. A wooded volcanic hill becomes the outer shell of an ancient machine. Terraces become courses, voids become chambers, slopes become faces. A summit complex becomes the surviving capstone of something much larger. The problem is not that comparison is forbidden. Archaeology depends on comparison. The problem begins when resemblance replaces demonstration. An Egyptian pyramid is not identified because it looks triangular from one direction. Its construction can be traced physically. Blocks were quarried, transported, laid in courses, and fitted into a planned mass. Foundations were levelled. Internal corridors were built according to coherent designs. Temples, causeways, enclosure walls, cemeteries, work areas, and settlements surrounded the main monument. Even where casing stones have disappeared and erosion has altered the surface, the remaining structure still reveals deliberate architecture from base to summit. Gunung Padang does not present that same pattern. Its slopes are irregular, heavily vegetated, and shaped by volcanic geology. The summit terraces are clearly organized, but they do not form the exposed upper courses of a continuous masonry pyramid. No complete base has been mapped. No four coherent faces have been excavated. No consistent angle extends around the entire landform. The shape changes according to viewpoint, terrain model, and the boundaries selected by the observer. From one direction, the hill may appear steep and symmetrical. From another, it blends into surrounding ridges. This does not mean the site lacks geometry. Human beings created geometry on the summit. They built terraces, alignments, boundaries, and routes. But geometry at the top does not prove that geometry continues through the entire hill. A temple built on a mountain does not make the mountain a temple. A terrace cut into a slope does not make the whole slope an artificial platform. The larger claim requires evidence at the larger scale. Measurements can become selective without anyone intending deception. A researcher may identify a line of slope that appears to continue beneath vegetation. Another line may be drawn from a terrace edge to a lower ridge. When several such lines are combined, a pyramid-like outline can emerge, yet natural terrain contains countless possible lines. The eye favours those that create familiar forms and ignores those that interrupt them. A digital model can make this tendency stronger by smoothing minor irregularities or emphasizing elevation bands. Scale also affects perception. A steep hill photographed from a low angle appears more monumental. Vegetation can hide gullies and uneven surfaces. Shadows create false edges. A cropped image may remove adjacent ridges that reveal the formation as part of a wider volcanic landscape. In diagrams, the hill can be isolated from its surroundings and converted into a clean geometric object. Once stripped of context, it begins to resemble a pyramid because the details that resist the comparison have been removed. The same process occurs below ground. Geophysical sections often contain bands, zones, and anomalies that can be outlined as separate layers. If those layers are interpreted as construction phases, the hill acquires an internal architecture, but geological formations also develop layers. Lava flows overlap. Weathering penetrates unevenly. Fractures fill with sediment. Landslides bury older surfaces. Hydrothermal alteration changes mineral composition. A volcanic hill can contain internal boundaries without having been built. The proposed Gunung Padang sequence divided the hill into several units, each assigned a different period of construction. The deepest core was treated as shaped or modified natural lava. Above it, other zones were interpreted as artificial fills or arrangements of stone. The visible terraces formed the youngest phase. This model created a long architectural history, but the boundaries between units depended heavily on how geological variation was classified. If the deeper units were natural, then the same cross-section would tell a story of volcanic formation, weathering, burial, and later summit modification rather than repeated pyramid construction. Pyramids built from stone usually reveal repetition. Courses continue, angles persist, joints follow structural logic. Internal spaces relate to the monument's overall plan. Gunung Padang's buried anomalies have not yet produced such a coherent system. A possible cavity in one area does not establish a chamber network. A dense layer in one core does not prove a wall extending around the hill. An inclined zone does not become a pyramid face unless its geometry can be traced and confirmed. The comparison also raises the question of function. Egyptian pyramids belong to royal funerary complexes. Mesoamerican pyramids often supported temples and were rebuilt in stacked phases. Mesopotamian ziggurats raised sacred buildings above surrounding settlements. Andean platform mounds organized ritual and civic space. These monuments may share stepped or sloping forms, but their construction methods and cultural roles differ greatly. Shape alone does not unite them into one architectural tradition. Gunung Padang's visible summit may be better understood as a terraced sacred landscape. Its ascending platforms fit regional traditions of elevated ritual space. The builders worked with an existing hill rather than necessarily concealing a complete artificial monument beneath it. This interpretation explains the visible stonework without requiring a missing royal culture, lost construction industry, or vast buried masonry system. Popular theories often reverse the burden of proof. Because the hill looks pyramid-like, skeptics are asked to prove that it is natural. Because instruments detect anomalies, critics are asked to prove that no chambers exist. Because old carbon was found at depth, archaeologists are asked to prove that no Ice Age builders were present. Science does not work by forcing every natural explanation to eliminate every imaginable human possibility. The proposed artificial structure must be demonstrated through positive evidence. There is also a cultural cost to forcing the Egyptian comparison. Gunung Padang becomes valuable only if it surpasses Giza in age. Indonesian megalithic traditions are treated as secondary unless they can be transformed into evidence of a global lost civilization. The site's actual architecture, local geology, and regional history are pushed aside by a competition it never needed to enter. The phrase older than Egypt is especially misleading because Egypt is not a universal starting line. Monumental construction appeared independently in many regions. A site can be older than Egyptian pyramids without being a pyramid. It can be important without overturning civilization. It can preserve a local tradition without belonging to a vanished global culture. Age and significance are not the same thing, and resemblance does not establish ancestry. Scholars still debate how extensively Gunung Padang was modified, how many construction phases exist near the summit, and whether some buried features deserve further excavation. Those questions remain legitimate. What the current evidence does not support is the confident transformation of the whole volcanic hill into an Egyptian-style monument. The resemblance is partial, dependent on viewpoint, and strengthened by expectation. The pyramid identity may therefore exist most clearly in the modern act of looking. Once the hill is framed as a pyramid, every feature is recruited into the pattern. The summit becomes a peak, terraces become steps, natural columns become masonry, internal variation becomes construction, old soil becomes a foundation date. The site begins to resemble the theory used to describe it. Testing the monument means resisting that circular pull. It requires comparing the hill not only with famous pyramids, but also with volcanic landforms, terraced ritual sites, landslide deposits, columnar rock formations, and sacred mountains modified by human hands. When those comparisons are widened, Gunung Padang no longer appears as a simple copy of Giza hidden beneath tropical soil. It becomes something more difficult to classify, a real megalithic complex built upon a natural hill whose deeper history remains uncertain. That uncertainty is less dramatic than the image of an Ice Age pyramid, but it is more faithful to the evidence. The site may contain buried terraces, reused stone, earlier activity surfaces, or unexplored cavities. None of these possibilities requires the entire landform to be artificial. The pyramid comparison has helped draw attention to Gunung Padang, but it may also have narrowed the questions researchers ask. The hill does not need to resemble Egypt to deserve investigation. It needs to be understood on its own terms. Understanding the hill on its own terms became increasingly difficult once its proposed age escaped the boundaries of specialist debate. A cautious statement about possible buried phases could be compressed into the claim that a pyramid had been discovered. A disputed radiocarbon sample could become the construction date of the entire monument. An anomaly detected inside a volcanic hill could be renamed a chamber. Each change removed a layer of uncertainty, and each removal made the story easier to repeat. By the time Gunung Padang reached a global audience, the conclusion often appeared settled before most readers had encountered the evidence. The oldest numbers carried the greatest power. A monument 9,000 years old would already predate Egypt's pyramids by several millennia. A monument 16,000 years old would belong to a period before the widespread establishment of agriculture. A structure 25,000 years old would push monumental engineering deep into the last ice age. The difference between these dates mattered less in popular discussion than the general promise that accepted history was wrong. The farther the claim moved into the past, the more attractive it became. Numbers also provided the appearance of precision. The phrase, perhaps very ancient, invites caution. The phrase 27,000 years old sounds like a measurement. Yet the dramatic figure did not come from dating a carved foundation stone, a wooden beam sealed inside a wall, or charcoal resting on a prepared floor. It emerged from radiocarbon measurements of organic material in deep deposits whose architectural identity was disputed. That qualification rarely survived into headlines. Media systems reward simplicity. A story about uncertain relationships between volcanic geology, soil formation, geophysical interpretation, and archaeological context is difficult to summarize. A story about the world's oldest pyramid is immediate. It offers a familiar object, a record-breaking date, and a conflict between courageous discoverers and a supposedly resistant establishment. The resulting narrative requires almost no knowledge of Indonesian archaeology. Anyone who recognizes the pyramids of Egypt can understand the promise that something older has been found. The phrase history must be rewritten often accompanies such claims because it converts an unresolved scientific argument into a cultural event. It suggests that experts have overlooked or suppressed an entire chapter of humanity. Archaeological caution becomes evidence of closed-mindedness. Requests for clearer stratigraphy or more excavation are reframed as refusal to accept discovery. The slower work of testing alternatives appears timid beside the excitement of revolution. This pattern does not require journalists or researchers to act dishonestly. Scientific studies are often complicated, while public communication rewards memorable conclusions. Researchers may emphasize the most ambitious interpretation because it attracts attention, funding, and further investigation. Reporters may shorten technical explanations to fit limited space. Editors may choose the most dramatic headline. Audiences then repeat the headline without reading the article. At every stage, uncertainty is reduced until the claim becomes stronger than the evidence that produced it. Gunung Padang also entered a larger collection of stories about lost civilizations. In these narratives, the end of the Ice Age destroyed an advanced society whose survivors carried knowledge to later cultures. Similarities between pyramids, flood traditions, astronomical alignments, and megalithic sites are treated as fragments of a forgotten global system. The lack of ordinary archaeological remains becomes part of the mystery rather than a problem for the theory. Missing tools, settlements, workshops, and writing are explained through catastrophe, rising seas, tropical decay, or deliberate suppression. Some elements behind these stories are rooted in real events. Sea levels rose dramatically after the last glacial maximum. Large areas of Sunderland disappeared beneath the ocean. Human populations moved as coastlines changed. Floods, volcanic eruptions, earthquakes, and tsunamis shaped Southeast Asian memory and settlement. Ancient communities exchanged ideas and materials over long distances. What the evidence does not establish is a technologically advanced Ice Age civilization responsible for Gunung Padang or for monumental architecture across the world. The lost civilization framework can make almost any uncertainty appear supportive. If a cavity has not been entered, it may contain hidden knowledge. If excavation finds no expected artifacts, the evidence may lie deeper. If geology offers a natural explanation, the formation may have been deliberately chosen and modified by ancient engineers. If a study is criticized, the criticism may be presented as institutional resistance. A theory that converts every objection into confirmation becomes difficult to test because nothing can count against it. National identity added another dimension. Archaeology often carries political meaning because ancient sites become symbols of depth, achievement, and belonging. The possibility that Indonesia contained the world's oldest pyramid offered more than a scientific discovery. It promised a civilization that could stand before Egypt and Mesopotamia in the global imagination. For a country whose ancient history is often represented internationally through later temple complexes and colonial-era scholarship, Gunung Padang could become evidence of a far deeper and more independent greatness. Pride in local heritage is not itself a problem. Indonesian megalithic traditions deserve greater attention, and local communities have long understood the importance of landscapes overlooked by outsiders. The danger begins when national significance becomes tied to the oldest or largest possible interpretation. A terraced ceremonial complex may then seem insufficient. To matter globally, the hill must become a pyramid. To represent civilizational achievement, it must be tens of thousands of years old. This pressure can narrow archaeological discussion. Researchers who question the Ice Age chronology may be portrayed as diminishing Indonesian history, even when they accept the summit's genuine human construction. Geological explanations can be mistaken for denial of cultural achievement, yet acknowledging a natural volcanic hill does not erase the people who transformed its summit. Human creativity often consists precisely in recognizing the possibilities of an existing landscape. The political and cultural setting also influences which questions receive attention. A claim that promises to rewrite world history can attract government interest, funding, tourism, and media coverage. More modest questions about terrace chronology, local ritual traditions, stone transport, or relationships with nearby communities may appear less urgent. Excavation becomes directed toward proving or disproving a pyramid rather than understanding the full history of the site. Tourism further strengthens the dramatic identity. Visitors are drawn to mysteries, and a possible Ice Age pyramid offers an experience more marketable than a complex debate about megalithic terraces. Guides, online videos, and promotional material may repeat the oldest proposed dates because those are what audiences remember. Over time, the claim becomes part of the place itself. People arrive already knowing what they expect to see, and the hill is interpreted through that expectation. The title world's oldest building creates another distortion. A building is usually understood as an enclosed or clearly constructed space. Gunung Padang's visible terraces are monumental modifications of a summit, but describing the whole hill as a building depends on the disputed buried architecture. The record-breaking title therefore assumes the conclusion it claims to announce. It also ignores the difficulty of comparing structures with entirely different forms and purposes. By late 2023, the hypothesis had acquired the features of a complete historical narrative. An ancient population shaped the volcanic core. Later builders added layers. Successive cultures inherited the monument. The final communities arranged the summit terraces. Catastrophe or social change erased the builders, leaving geology to conceal their work. Modern instruments then rediscovered what conventional archaeology had missed. It was an elegant story. Its weakness was that the deepest chapters were reconstructed from evidence that could also be explained by natural formation. The more detailed the story became, the easier it was to forget where observation ended. Instruments had detected contrasts. Drill cores had recovered ancient deposits. People had undeniably constructed the upper terraces. From those facts, an entire sequence of lost builders was inferred. No settlement belonging to the earliest phase had been found. No secure tool assemblage demonstrated their engineering. No exposed chamber confirmed the geophysical interpretation. No continuous deep masonry system had been excavated. What survives in the public imagination often bears little resemblance to this uncertainty. The pyramid becomes a fact awaiting official acceptance. The date becomes a known age rather than a disputed association. The reappearance of the claim in later articles gives the impression that new discoveries have strengthened it, even when the same withdrawn evidence is merely being repeated. Gunung Padang thus became a case study in how an archaeological possibility can grow beyond excavation. The process was driven by genuine wonder, scientific ambition, commercial attention, cultural pride, and the human desire to find a forgotten beginning. None of these forces alone explains the controversy. Together, they created a version of the hill more complete and more ancient than the material record allowed. The most revealing question was no longer only whether a pyramid lay beneath the summit. It was how a disputed interpretation had become so resistant to correction. Answering that required the scientific community to examine not just Gunung Padang, but also the processes that had allowed extraordinary conclusions to pass through publication and enter the world with the authority of peer-reviewed research. The backlash did not begin because archaeologists believed early people were incapable of building monuments. It began because the evidence presented for Gunung Padang did not securely connect the deepest dated deposits to human construction. That distinction was central, yet easily lost in public debate. Critics were not denying the visible terraces, the human arrangement of stone on the summit, or the possibility that the site contained more than one phase of activity. They were challenging the leap from geophysical anomalies and ancient soil to a vast artificial pyramid built during the Ice Age. The first wave of criticism focused on identification. Before a buried layer could be dated as architecture, researchers had to demonstrate that it was architecture. Volcanic hills contain fractured rock, weathered zones, buried soils, lava contacts, voids, and deposits moved by gravity or water. These features can appear structured in cores and geophysical sections. If the same evidence can be explained by ordinary geological processes, the human-made interpretation requires additional proof-consistent masonry, prepared surfaces, construction fills, tool marks, associated artifacts, or repeated spatial patterns that natural formation cannot readily produce. Critics argued that the 2023 study treated some disputed geological features as construction units, too early in the reasoning process. Once those units were labelled as phases of a pyramid, radiocarbon dates from soil within them were interpreted as ages of building. But if the units were natural, the dates had an entirely different meaning. They might record ancient vegetation, sediment formation, or organic matter trapped in the hill. The scientific dispute therefore concerned not merely the reliability of the dates, but the identity of the thing being dated. Archaeologists also question the scarcity of cultural material associated with the proposed deep phases. A monumental project extending through much of the hill should have generated a broad human signature. Workers would need tools, food, temporary occupation areas, paths, extraction zones, and places to process stone. Construction would create debris. Repeated use might leave hearths, compacted surfaces, discarded objects, or repairs. Tropical conditions can destroy organic remains, and limited excavation can miss important deposits. But the proposed scale made the near absence of securely connected evidence increasingly difficult to explain. Geologists emphasize that columnar volcanic rock can mimic masonry. Natural cooling fractures create elongated blocks with relatively regular faces. Weathering separates them. Slope movement rearranges them. Sediment fills the spaces between them. In a narrow trench or drill core, such material can resemble intentional packing. The correct test is not whether the stone looks organized in one exposure, but whether the organization continues across a broader area and follows structural logic rather than geological fracture patterns. The proposed cavities received similar scrutiny. A low-density or high-resistivity anomaly could be consistent with an open chamber, but it could also indicate fractured rock, dry void space, a weathered zone, or differences in moisture, without direct entry, excavation, or clearer architectural boundaries. The term chamber went beyond what the instruments could establish. Remote sensing had identified areas worth investigating. It had not photographed sealed rooms inside a pyramid. The strongest institutional response arrived on March 18, 2024, when the journal issued a formal retraction of the 2023 paper. The decision centered on the lack of reliable association between the radiocarbon-dated soil and artifacts, human activity, or structures proven to be anthropogenic. The statement did not declare that Gunung Padang contained no archaeology. It did not deny the surface monument. It concluded that the evidence presented could not support the claim that a pyramid had been built 9,000 years ago or earlier. The authors disagreed with the retraction. Their opposition mattered because scientific controversies are rarely resolved by a single announcement. They continued to defend their interpretation of the geophysical data, core samples, and proposed construction sequence. Supporters argued that the journal had acted too aggressively and that further excavation might vindicate the model. Critics replied that future discoveries could not retroactively supply evidence missing from the published paper. A hypothesis may remain open to testing even when a specific article supporting it is withdrawn. This distinction is essential. Retraction does not prove the opposite of every claim in a paper. It signals that the published work should no longer be treated as a reliable contribution in its original form. Gunung Padang might still contain unknown buried features. Some human modification may extend deeper than currently confirmed. Earlier activity could survive beneath the summit terraces. What the retraction removed was the scientific authority of the specific chronology that had transformed disputed soil layers into a 20,000-year-old pyramid. The case also raised uncomfortable questions about peer review. The paper had passed through a scientific journal before specialists publicly challenged its central associations. Peer review is often misunderstood as a stamp proving that a study is correct. In reality, it is a filter conducted by a limited number of reviewers working within time and expertise constraints. Reviewers can miss problems. A paper may use sophisticated instruments and statistical methods, while depending on an archaeological interpretation that has not been tested strongly enough. Publication begins scrutiny. It does not end it. A later academic reflection on the controversy treated Gunung Padang as a warning about archaeological prospection. Geophysical methods can produce visually compelling models, and those models can encourage researchers to assign architectural meaning before excavation confirms it. The more dramatic the interpretation, the more important it becomes to separate measured properties from reconstructed structures. A resistivity zone is a resistivity zone before it is a wall. A radar reflection is a reflection before it is a floor. A void is a physical contrast before it is chamber. The controversy also exposed the risks of disciplinary imbalance. A study may combine geology, seismology, geophysics, drilling, dating, and archaeology. But each field has its own standards of inference. A geologist may identify a disturbed layer without being able to determine whether people disturbed it. A geophysicist may map an anomaly without knowing its cultural meaning. A dating laboratory may produce a valid age without establishing the sample's relationship to construction. Archaeology is the discipline that must connect those observations to human behavior through context. When that connection is weak, technical sophistication can create false confidence. Colorful three-dimensional models, calibrated dates, and detailed unit names may make a reconstruction appear more secure than it is. The problem is not the use of advanced methods. The problem is allowing the output of those methods to outrun direct evidence. At Gunung Padang, critics argued that the interpretation became more precise than the archaeology allowed. The backlash was sometimes portrayed as a defense of conventional history. But the scientific objections were more practical. Where were the unequivocal deep walls? Where were the prepared floors? Where were the construction tools, occupation traces, or securely associated cultural materials? Could the proposed units be reproduced across independent trenches and cores? Did the anomalies match known volcanic structures? Were alternative geological explanations tested with equal seriousness? These were not attempts to preserve Egypt's status. They were basic questions about how claims are verified. The debate also revealed why extraordinary claims require evidence that is not merely unusual, but discriminating. An old date is unusual. A geophysical anomaly is unusual. A geometric hill is unusual. But none of these alone distinguishes an Ice Age pyramid from a natural volcanic formation later modified at the summit. Strong evidence must favour one explanation over its alternatives. A fitted wall with a prepared base, sealed cultural deposit, and secure construction date would do that. Ancient soil within fractured rock does not. No single explanation fully accounts for every feature reported inside the hill, and the scientific backlash should not be mistaken for a final map of Gunung Padang's interior. Much remains untested. Limited excavation leaves room for genuine surprises. Yet uncertainty cannot be filled automatically with the most dramatic possibility. It must remain uncertainty until the evidence narrows it. The controversy ultimately strengthened one conclusion while weakening another. It reinforced the importance of the visible megalithic complex, which rests on direct observation and established human arrangement. It weakened the claim that the entire hill had been built in multiple phases beginning during the Ice Age. By separating those two ideas, the backlash did not destroy Gunung Padang's significance. It removed a speculative superstructure that had begun to overshadow the actual archaeology. What remained after the retraction was not an empty hill, but a more honest mystery. The summit was still ancient. The terraces were still human-made. The buried anomalies still deserved careful investigation. The unanswered questions had not disappeared. They had simply become narrower, harder, and more scientifically useful than the sweeping claim that first carried the site around the world. Once the 27,000-year pyramid is set aside, Gunung Padang does not become simple. The withdrawal of an extraordinary chronology narrows the mystery, but it does not eliminate the possibility that the hill preserves a more complicated human history than the visible terraces alone reveal. Archaeology often advances this way. A grand explanation fails, yet smaller questions survive beneath it. Those questions may be less spectacular, but they are also more precise. They ask where human modification begins, how many phases of construction exist near the summit, whether buried terraces extend farther down the slopes, and whether earlier visitors used the hill before the best-known monument took shape. The first unresolved issue is the full extent of the megalithic complex. The 5 principal terraces are the clearest features, but stone alignments, displaced columns, retaining edges, and possible paths occur beyond the most obvious summit platforms. Vegetation, erosion, later disturbance, and uneven documentation make it difficult to determine which features belong to one coherent plan. Some stones may have fallen from higher levels. Others may have been moved during repairs, farming, tourism development, or earlier investigations. A line that appears architectural may continue beneath soil or dissolve into natural rock after only a short distance. Careful mapping could clarify these relationships. High-resolution terrain models, detailed stone-by-stone plans, microscopic examination of sediment, and controlled excavation around selected walls might reveal whether the summit expanded gradually. A terrace edge buried beneath later fill could indicate an earlier, smaller monument. A wall repaired with differently placed stones might preserve several periods of maintenance. A path that cuts through an older arrangement could show how movement across the site changed over time. Such findings would not prove a pyramid, but they would produce a richer construction history. The visible monument may be the result of repeated rebuilding rather than a single project. Sacred places often accumulate in this way. Stones are moved, boundaries shift, surfaces are resurfaced, and later communities preserve some features while abandoning others. The finished form seen today may represent only the last recognizable stage of a much longer sequence. The chronology of the upper terraces remains another open problem. Their broad classification as megalithic does not provide a precise date. Similar stone-building traditions can persist for long periods, and objects recovered from disturbed deposits may not date the original construction. Pottery or organic material found near a wall could belong to later visitors. A surface exposed for centuries can collect remains from many different episodes. To establish the age of a terrace, archaeologists need sealed context connected directly to its creation or earliest use. A small pocket of charcoal beneath a foundation stone might help, provided the charcoal was not residual material from older soil. Short-lived seeds sealed within construction fill would be stronger. Sediment trapped beneath a wall could establish that the wall is younger than the surface it covers. Several consistent samples from different parts of the same phase would be more persuasive than one isolated date. The goal is not simply to find the oldest carbon, but to build a sequence in which each layer has a clear relationship to the next. There may also be older human activity beneath the monument that does not involve monumental construction. People could have camped on the hill, lit fires, gathered plants, hunted nearby, or placed small ritual deposits before anyone built formal terraces. Later builders might have disturbed or buried those traces. If ancient charcoal, stone tools, or compacted surfaces were found beneath the summit complex, they could demonstrate earlier use without supporting the idea that the entire hill was already a pyramid. This distinction matters because human presence is not the same as architecture. Archaeological sites often contain long gaps between occupation and construction. A cave may be visited for thousands of years before walls are added. A hilltop may serve as a lookout or meeting place long before terraces formalize its importance. Older activity beneath Gunung Padang would deepen its history while leaving the geological hill itself natural. The reported subsurface voids remain among the most intriguing unresolved features. Geophysical data suggest that parts of the hill differ in density, electrical resistance, or internal structure. Some anomalies may reflect natural fractures or spaces between volcanic blocks. Others could result from later collapse, animal burrowing, groundwater movement, or weathered zones. A smaller number might prove to be human-modified cavities, but that possibility requires direct testing. Accessing a suspected void is technically and ethically difficult. Drilling can damage fragile deposits or provide only an ambiguous glimpse. Excavating from the surface may require removing large amounts of overlying material. A robotic camera can enter only if a safe passage is identified. Any opening might destabilize surrounding rock or alter moisture conditions. The hill is also a protected cultural landscape, not an engineering test site that can be cut apart without restraint. A genuine human-made chamber would need more than empty space. Its boundaries should show shaping, lining, support, or regular geometry. Sediment inside might contain artifacts, soot, organic material, or evidence of repeated entry. A passage might reveal wear or deliberate closure. Even a natural cavity could have been used by people, creating a mixed feature in which geology supplied the space and human activity gave it cultural meaning. Scholars still debate these possibilities because no confirmed deep chamber has yet been entered and documented. The deeper stone layers present a similar problem. Some may be natural volcanic units, while others could contain localized human disturbance. Ancient builders may have taken advantage of exposed columns, rearranging stone only where necessary. Later slope movement could then mix constructed and natural material. In such a setting, the boundary between geology and archaeology may not be a clean line. Human intervention could appear in scattered pockets rather than as one continuous artificial shell. Future research would therefore benefit from asking smaller questions at carefully chosen locations. Does a particular stone alignment continue for 10 meters? Does it rest on a prepared surface? Is the sediment behind it imported or local? Are the stones oriented differently from the natural joints? Does a buried platform connect with a visible terrace? Can multiple laboratories reproduce the same dates from secure contexts? These questions may appear modest compared with the claim of an Ice Age pyramid, but they are capable of producing answers. Independent investigation is equally important. Extraordinary interpretations become stronger when different teams, using different methods, reach similar conclusions. New surveys should publish complete data sets, explain how processing choices affect the resulting images, and test geological alternatives. Core descriptions should be detailed enough for outside specialists to evaluate. Excavation records should document exact sample locations and stratigraphic relationships. Transparency would allow the debate to move away from competing declarations and toward features that can be checked. The 2025 geoarchaeological preprint offered one possible reassessment, suggesting that the main body of the hill is volcanic, while human modification may be concentrated in later and shallower contexts. Because the work had not completed full peer review, it could not settle the issue. Its value lay in shifting attention back toward depositional integrity, geological formation, and the question of whether dated material remained in its original context. It suggested a direction for testing rather than a final verdict. There are also unanswered cultural questions above ground. Who built and used the summit terraces? Were they connected with nearby communities through pilgrimage, exchange, or political authority? Did different groups return to the site over centuries? Were particular stone arrangements linked to ancestors, celestial events, healing, territorial boundaries, or seasonal gatherings? Without writing or a rich artifact assemblage, meaning must be reconstructed cautiously from spatial organization, regional comparison, and traces of use. Local oral traditions may preserve later memories of the site, but they cannot be projected unchanged into remote prehistory. Stories evolve, names shift, and sacred places attract new associations as political and religious worlds change. Even so, these traditions are part of Gunung Padang's history. They show how later communities continue to interpret the hill and may help explain why certain areas remained respected, avoided, visited, or rebuilt. What Gunung Padang still conceals may therefore be more humanly interesting than a single hidden pyramid. The hill could preserve a sequence of visits, modifications, repairs, and changing beliefs extending across many generations. Its deeper deposits may contain ancient environmental records, evidence of slope movement, buried soils, and scattered traces of human activity. Some anomalies may prove natural, others may reveal construction more extensive than currently documented. The answer may be a mosaic rather than a monumental secret. The rejected claim imagined one great discovery capable of rewriting civilization. The genuine questions point towards slower history people returning to a prominent hill, arranging local stone, transforming paths and platforms and leaving behind a place whose meaning outlived their names. That history is harder to compress into a headline, but it is also less fragile. It does not depend on one ancient soil sample or one coloured image of the underground. It waits in relationships between stones, sediments, surfaces, and human traces that future investigation may still bring into focus. The power of Gunung Padang does not come only from stone, soil, or disputed dates. It comes from the shape the modern imagination places over them. A hill that narrows toward a summit, a sequence of terraces, a cluster of long rocks, and an unexplained anomaly beneath the ground can quickly become a pyramid, because the pyramid is one of the strongest symbols humanity has inherited from the ancient world. It is simple enough to recognize, mysterious enough to invite speculation, and old enough to suggest knowledge that has been lost. Once that form appears, even imperfectly, the landscape begins to feel like a message. Pyramids have this effect partly because they seem both human and geological. Their broad bases and rising sides resemble mountains, yet their symmetry implies design. They appear permanent, but their interiors are hidden. They can dominate a horizon while concealing most of their meaning. A pyramid therefore sits between nature and architecture in much the same way Gunung Padang does. It looks like something people could build, while also appearing too large, too stable, or too ancient to belong entirely to ordinary human life. The form emerged independently in several parts of the world because it solves a practical problem. A wide foundation supports height. Stepped platforms are easier to stabilize than vertical walls. Successive building phases can expand outward and upward. A mound, terrace, temple platform, or tomb can gradually acquire a pyramid-like profile without its builders sharing any connection with Egypt. Yet repeated shape encourages repeated stories. Similar forms are treated as evidence of a forgotten source, a global teacher, or survivors of an advanced civilization spreading knowledge across oceans. This interpretation is appealing because coincidence feels unsatisfying. People prefer a hidden connection to the possibility that separate communities face similar engineering challenges and reached similar solutions. A stepped monument in Indonesia, a platform mound in Peru, a temple in Mesoamerica, and a royal tomb in Egypt may all rise toward the sky, but they belong to distinct environments, materials, social systems, and beliefs. Their resemblance is real. The claim that it proves a common lost civilization is not. Gunung Padang entered this symbolic world as soon as the natural hill was called a pyramid. The word placed it into a network of familiar mysteries: Atlantis, vanished continents, ancient global navigation, forgotten technologies, and catastrophic floods that erased civilization before history began. In that network, the site no longer needed to be understood primarily through West Javan geology or Indonesian megalithic traditions. It could be connected to every monumental structure whose origin seemed strange, distant, or insufficiently explained. The end of the Ice Age provides a particularly powerful background for these stories because genuine transformation occurred. Sea levels rose, coastlines disappeared, Sunderland was flooded, human communities moved across landscapes that now lie beneath the sea. Rivers changed, forests shifted, and entire territories vanished from human access. Archaeologists know that large parts of prehistoric settlement may be submerged and difficult to study. This real loss creates space for imagined losses on a much greater scale. A vanished coastal camp is archaeologically plausible. A drowned network of settlements is likely in many regions. A complex society erased so completely that only disguised pyramids remain is a much larger claim. Yet the emotional distance between these possibilities is small. Once people accept that landscapes disappeared beneath rising seas, it is tempting to populate them with cities, monuments, and advanced knowledge. The missing archaeological record becomes evidence of destruction rather than a reason for caution. Uncertainty strengthens these stories because it leaves room for participation. A fully excavated wall with a clear date and known function offers less imaginative freedom than an unopened anomaly. A chamber entered and found empty becomes ordinary. A chamber that may exist can contain anything. The unknown invites each observer to complete the evidence according to personal hopes, fears, and beliefs. In this sense, uncertainty is not merely a weakness in the Gunung Padang story. It is one of the reasons the story survives. Scientific caution can unintentionally deepen the mystery. When researchers say that a cavity is unconfirmed, audiences may hear that a hidden chamber remains possible. When archaeologists explain that the evidence is incomplete, the phrase may sound like an admission that proof is waiting just beyond the next excavation. When a paper is withdrawn, supporters may interpret the decision as controversy rather than correction. The absence of certainty keeps the dramatic interpretation alive because it has not been disproved in every imaginable form. This creates an uneven contest between archaeology and speculation. Archaeology must connect each claim to physical context. It must distinguish natural from human processes, explain sampling, test alternatives, and accept conclusions that remain partial. Speculation can move in the opposite direction. It begins with a complete story and uses isolated details to decorate it. A stone line becomes a wall, a gap becomes a chamber, a date becomes a civilization. Each uncertainty is absorbed rather than resolved. The pyramid is especially suited to this process because it already carries the expectation of hidden interiors. Egyptian monuments contain passages, relieving spaces, shafts, and chambers. Mesoamerican pyramids often conceal earlier structures inside later rebuilding. Archaeologists have discovered rooms and tunnels in monuments long after their construction. These real discoveries make it reasonable to wonder whether other pyramid-like forms contain hidden spaces. They do not make every anomaly architectural, but they provide a powerful template for hope. There is also a desire to recover a more dramatic human past. The established archaeological record is already filled with extraordinary achievements, but those achievements developed gradually, regionally, and unevenly. Communities experimented, failed, rebuilt, migrated, and adapted. Their histories contain long periods without cities or monumental states. Lost civilization narratives replace that slow complexity with a sudden revelation. Advanced knowledge existed far earlier, then disappeared. Such stories can feel respectful toward prehistoric people because they reject the idea that ancient humans were unintelligent, yet they often replace known societies with imaginary ones. The actual builders of Gunung Padang's terraces become less interesting than hypothetical Ice Age architects. Local traditions become fragments of a global system. Regional innovation becomes inheritance from vanished masters. The attempt to honor the past can therefore erase the people whose work is genuinely present. A similar pattern appears at natural formations around the world. Underwater rocks become roads or temple walls. Mountains are interpreted as artificial pyramids. Regular fractures are described as masonry. Eroded caves become engineered tunnels. Human perception is extremely sensitive to pattern, especially straight lines, symmetry, faces, and familiar structures. This ability is essential for survival and creativity, but it can also turn geology into intention. The most durable mysteries often combine three ingredients: a real archaeological feature, an incomplete explanation, and a larger cultural symbol. Gunung Padang possesses all three. Its summit is genuinely constructed. Its chronology and deeper extent are not fully resolved. Its hill resembles one of humanity's most iconic monumental forms. The resulting story is stronger than a pure invention because it is anchored to something real, yet flexible enough to expand beyond what has been demonstrated. Proof can sometimes weaken fascination because it narrows possibility. Once a structure is dated, mapped, and placed within a regional culture, many imagined histories disappear. Uncertainty preserves them all at once. The hill can remain a ritual centre, a buried pyramid, a surviving fragment of Sunderland, a tomb, a chambered monument, or evidence of a forgotten civilization, depending on who is looking. The evidence does not support all these versions equally, but the landscape is spacious enough to hold them in the public imagination. This does not mean mystery should be eliminated. Wonder is one of the forces that draws people toward archaeology. It encourages exploration, preservation, and attention to places that might otherwise be ignored. The challenge is to allow wonder without allowing it to replace method. A mystery becomes more meaningful when its limits are understood. Gunung Padang is not diminished by separating what is visible from what is imagined. The hill may never provide the single revelation many people expect. Its importance may emerge through smaller discoveries: a repaired terrace, an older path, a ritual deposit, a buried surface, or evidence that different communities returned across centuries. These findings would not confirm a lost civilization, but they would recover human decisions that are otherwise almost invisible. The enduring fascination of pyramid-shaped landscapes reveals as much about the present as the past. People look toward ancient stone hoping to find continuity, catastrophe, wisdom, and proof that history is larger than textbooks allow. Sometimes archaeology answers with a chamber, a city, or a forgotten culture. More often, it answers with layers, uncertainty, and the patient reconstruction of lives whose names are gone. Gunung Padang stands at the meeting point of those desires. Its terraces invite belief, its geology resists simple classification, and its unexplored spaces allow stories to continue. Yet the most honest mystery is not whether a vanished super-civilization built a pyramid beneath the hill. It is how real communities transformed a volcanic summit into a place powerful enough to inspire new meanings long after the original builders disappeared. After the instruments, dates, headlines, objections, and unanswered questions, Gunung Padang returns to the same quiet form in which it began: a forested volcanic hill crowned by terraces of dark stone. The summit remains real. The human labour remains real. The deeper pyramid does not, at least, not as an established archaeological conclusion. The strongest assessment supported by the evidence is that ancient communities deliberately arranged thousands of naturally formed volcanic columns into a stepped megalithic complex, creating pathways, retaining walls, platforms, and spaces that probably carried ceremonial or social meaning. What has not been demonstrated is that the entire landform beneath those terraces was constructed as a pyramid, or that its deepest layers were engineered by people during the last ice age. That conclusion can feel unsatisfying only because the most dramatic claim has changed the scale by which the site is judged. A genuine megalithic monument on a volcanic summit should be remarkable. It represents coordinated labour, environmental knowledge, social memory, and a long relationship between communities and landscape. Yet once the hill is described as a 25,000-year-old pyramid, the visible terraces begin to seem like a minor detail. Archaeology is then asked not to explain the monument that exists, but to prove the civilization imagined beneath it. The evidence does not currently support that imagined civilization. The ancient radiocarbon measurements came from organic material in deep soil, not from a securely identified Ice Age floor, mortar, hearth, foundation trench, or human-made wall. The geophysical anomalies show internal differences within the hill, but they have not been converted through excavation into a coherent system of chambers and masonry. The core samples reveal complex deposits, but natural volcanic formation, weathering, fracture, and slope movement remain plausible explanations for much of that complexity. No securely associated Ice Age tools, workshops, living surfaces, or construction debris establish the human world required by the proposed pyramid. The paper that gave the extraordinary chronology formal scientific standing was retracted on March 18, 2024. The central problem was not that old carbon had been measured incorrectly, but that the dated material had not been connected reliably to structures proven to be artificial. The authors disagreed with the decision, and disagreement is part of science. Yet the retraction changed the status of the claim. The dates could no longer be repeated responsibly as confirmed ages for a pyramid. By July 2026, no new peer-reviewed investigation had reversed that decision or supplied independent archaeological proof of monumental Ice Age construction inside the hill. A preliminary reassessment published without full peer review suggested a more restrained interpretation. The main body of Gunung Padang is volcanic, while human intervention may belong primarily to shallower and later phases. That possibility fits the evidence more comfortably, but it too must remain open to testing. The responsible conclusion is not that every anomaly has been explained. It is that uncertainty survives without validating the largest claim. Future excavation could still change parts of the picture. A buried terrace might extend farther down the slope than expected. A wall could appear beneath later deposits. Earlier occupation surfaces may survive under the visible monument. A cavity may prove to have been modified or used by people. Secure samples from construction contexts could revise the chronology of particular features. Archaeology has produced enough surprises to make absolute declarations unwise. But future possibility is not present evidence. A discovery that may occur cannot be treated as though it already has. The best way forward is to test small, precise predictions. If a buried wall exists, it should continue beyond a single core or coloured survey zone. If a chamber exists, it should have boundaries, an entrance, or internal surfaces distinct from natural fractures. If an early construction phase exists, its stone should show arrangement, foundation, and association with cultural remains. If radiocarbon dates belong to building, the sample should come from context created by that building. Each test can move the argument toward clarity. None requires beginning with the assumption that the hill is a pyramid. Gunung Padang also deserves protection from the controversy surrounding it. Excavation undertaken only to reach a sensational chamber could damage the confirmed monument above. Heavy intervention might destabilize terraces, disturb deposits, or erase the relationships needed to understand the site. The pressure to produce a dramatic result can encourage speed where archaeology requires patience. Preservation must come before spectacle, because the hill cannot be excavated twice. Local knowledge and community involvement should remain central as well. The site is not simply a scientific puzzle or tourist object. It belongs within a living cultural landscape. Generations have attached names, stories, practices, and identities to the summit. These traditions cannot date the stones by themselves, but they are part of the monument's later history and should not be displaced by a global narrative that treats Gunung Padang only as evidence for a vanished super-civilization. The story also offers a broader lesson about how archaeological knowledge is built. Scientific instruments can extend human sight beneath the surface, but they do not remove the need for interpretation. Radiocarbon dating can provide extraordinary chronological power, but only when the sample's relationship to human activity is secure. Peer review can improve research, but it cannot guarantee that every published conclusion is sound. Retraction can correct the record, but it cannot erase a dramatic claim from public memory. Once an idea becomes a headline, it may survive longer than the evidence that supported it. This is why the Gunung Padang controversy matters beyond one Indonesian hill. Archaeology increasingly depends on remote sensing, computer modelling, chemical analysis, and enormous datasets. These tools can reveal landscapes invisible to earlier generations. They can locate buried cities, map roads beneath forests, detect chambers, and reconstruct ancient environments. But sophisticated technology does not make interpretation automatic. The brighter the image and the more precise the number, the easier it becomes to forget that every conclusion still depends on context. The case reminds us that skepticism is not hostility toward discovery. It is the process by which discovery becomes reliable. When archaeologists ask for artifacts, stratigraphy, prepared surfaces, and repeated evidence, they are not defending an old timeline simply because it is old. They're asking whether a new claim explains a material better than its alternatives. Established history is not protected from change. It changes whenever evidence strong enough to survive these tests appears. Göbekli Tepe changed the history of monument building because its pillars, quarries, floors, deposits, and dates converged. Submerged landscapes have changed models of human migration because geology, environmental reconstruction, artifacts, and chronology align. Ancient DNA has transformed the human family tree because separate laboratories can recover and compare biological evidence. Archaeology welcomes revision, but revision must be earned by evidence that remains persuasive after the excitement has passed. Gunung Padang has not yet crossed that threshold for an Ice Age pyramid. Its deepest chronology rests on associations judged insufficient. Its internal architecture remains hypothetical. Its most dramatic scientific paper is no longer part of the accepted published record. The responsible verdict is therefore clear but not final. The summit contains an important megalithic complex built by human hands. The hill beneath it is principally a volcanic landform, whose degree of ancient modification remains under investigation, and no reliable evidence currently proves that it is a pyramid older than Egypt. That verdict leaves the site with dignity rather than disappointment. The ancient builders did not fail because they created terraces instead of a hidden superstructure. Their work does not become insignificant because it belongs to a regional tradition, rather than a forgotten global civilization. They took a summit formed by fire, stone, rain, and deep geological time, and turned it into a place where people gathered, moved upward, marked boundaries, and perhaps approached ancestors or sacred forces. That achievement is neither small nor ordinary. The hill does not need to rewrite all of history. It asks for something more difficult: that history be read carefully. Mist settles again across the terraces. The long stones darken under moisture, their sharp edges softened by moss, soil, and the slow return of vegetation. Beyond the summit, green ridges fade into cloud, while far below them lie landscapes shaped by rivers, volcanoes, movement, and memory. The people who arranged these stones are gone. Their names did not enter inscriptions. Their voices did not survive in a language that can be placed securely beside the walls. What remains is weight, alignment, elevation, and the evidence that this hill mattered enough for human hands to change it. Time has covered the rest unevenly. It has buried surfaces, shifted stones, opened fractures, carried soil into gaps, and allowed roots to enter places once clear. It has preserved old carbon without preserving the moments that placed it there. It has turned construction into ruin, and geology into something that can resemble construction. Over thousands of seasons, nature and culture have folded together until separating them requires patience, far greater than the excitement of discovery. Perhaps that is the final image Gunung Padang offers. Not a perfect pyramid waiting beneath the earth, but a meeting place between what the planet built and what people added. The hill rises because of volcanic forces older than humanity. The terraces exist because communities recognized something in that height and chose to shape it. Later generations looked upon the same stones and gave them new stories. Modern instruments looked deeper and found patterns that could not immediately explain themselves. Each age added another layer, not always in rock, but in meaning. Human history is fragile in this way. A settlement can disappear beneath water, a path can vanish beneath forest, a ritual can continue after its origin is forgotten. A scientific claim can outlive the study that produced it. Memory does not preserve the past intact. It preserves fragments, and people build around them. The temptation is always to fill the missing spaces with certainty, to name the builders, define the monument, date its beginning, and turn a complicated hill into one complete story. Yet some places endure precisely because they resist completion. Their silence is not proof of hidden civilizations, but neither is it emptiness. It is the distance between what happened and what can still be known. As evening settles over the summit, the terraces remain suspended between those two worlds. They are solid enough to touch, yet their purpose is partly lost. Beneath them, the volcanic hill holds old soils, broken stone, natural cavities, and perhaps traces still awaiting careful discovery. Above them, mist moves through the trees and erases the horizon. The oldest story here may not be the story of a pyramid at all. It may be the quieter story of people climbing a mountain, carrying stone, returning across generations, and leaving behind a place strong enough to survive them, but not clear enough to surrender all its meaning. The hill keeps that distance, the stones remain, and the unanswered past rests beneath them, not demanding belief, only patience,